Hey everyone, Chris Dutton here, and welcome to Microsoft Power BI, up and running with Power BI Desktop. Now, if you're looking for a hands-on, project-based approach to learning business intelligence, you've come to the right place. In this course, you'll be playing the role of lead analyst for AdventureWorks Cycles, a global manufacturing company. Your mission? Design and execute an end-to-end business intelligence solution from scratch. But the good news is, I'll be right there with you, guiding you through the ins and outs of Power BI and sharing crystal clear explanations and helpful pro tips each step of the way. Our journey will begin with an intro to Power BI Desktop and then transition through each phase of the business intelligence workflow. We'll begin by connecting and shaping our source data with Power BI's query editing tools, and then explore concepts like cardinality, normalization, and filter context as we build out a full-scale data model. From there, we'll add calculated columns and measures using data analysis expressions or DAX, and finally take things to the finish line by designing dynamic interactive reports using Power BI's visualization tools. So what do you say? Ready to dive in? Sign up today and get lifetime access to over 10 hours of high-quality video content, downloadable project files and resources, course quizzes and homework assignments, and one-on-one expert support, all backed by a 30-day, 100% guarantee. Thanks again for choosing this course. Now let's get started. All right, let's kick things off and talk about our course project. So here's the situation. You've just been hired by AdventureWorks Cycles. It's a global manufacturing company, and they want you to design and deliver an end-to-end business intelligence solution from scratch. Now, this won't be a simple project. The client needs a way to track core business KPIs like sales, revenues, profit, and returns, but also compare regional performance across sales territories, analyze performance and trending at the product level, and forecast future profits, and use the data to identify the company's high-value customers. And as if that's not challenging enough, all you've been given to work with is a folder of raw CSV files that contains information about transactions, returns, products, customers, and territories. But don't worry, we're going to work through this together. I'm here to coach you through each step of the way and break down the project into a few core objectives. So our mission here is to use Power BI Desktop to connect and transform the raw data from those CSV files, use those tables to build a relational data model to blend information together, create new calculated columns and DAX measures, and finally design an interactive report to actually analyze and visualize all of this data. So let me give you a little sneak preview of the project that we're actually going to be creating from a completely blank canvas. So what you're looking at here is the final deliverable that we're going to provide to our AdventureWorks clients. We've got an executive summary here that allows you to break down the data and explore information by categories, by product subcategories. We can see the core business KPIs, the revenue, order volume, and returns for the current month. We'll provide a quick snapshot of the most ordered products and the top revenue driving products, and include the ability to filter down the entire page by specific sales regions. Not only that, but we'll include drill through functionality to dive deeper into specific product performance and provide insight like pacing against targets, profit trending over time, and forecasts into the future, and even scenario tests to see the impact of pricing adjustments on actual bottom line company profits. Last but not least, we'll provide a view that's all about the AdventureWorks customer so that we can see the top revenue driving customers, breakdowns by demographics like gender, income level, and occupation. We'll see orders by age, top customers and top line metrics, and bookmarks and links to tie it all together. So again, we're going to be working through the business intelligence workflow together step by step to build this entire project from nothing but a folder of raw CSV files. I hope you're excited. We've got a lot ahead of us. Let's dive in. Last bit of housekeeping before we move on to the next section. Just want to take a minute to set some expectations for the course. Now, number one, what you see on your screen might not always exactly match what I'm showing on mine. Microsoft products are constantly changing and evolving, and Power BI Desktop is no exception. In fact, there are product updates released every single month, which means that you're likely to see some differences in the layout or the tools or the functionality over time. Second, important note, Power BI is currently only compatible with Windows machines. At this point in time, there isn't a Mac version of Power BI Desktop available. Number two, as the title suggests, this course is designed to get you up and running with Power BI Desktop. Now, my goal is to give you a deep foundational understanding of the tool, so I may simplify some concepts, and I won't cover some of the more advanced tools. So we won't be writing any custom M scripts, we won't be importing custom R visuals, we're going to skip over some of the more advanced or nuanced DAX functions. That said, I'm confident that the concepts covered in this course will give you an excellent starting point for those types of more advanced applications. Number three, Power BI and Power Pivot in Excel are built on top of the exact same engine. So if you've taken my Power Query, Power Pivot, and DAX course, these first few sections will feel very, very familiar. We're going to talk about the same query editing tools, we're going to talk about the same data modeling fundamentals, and we'll review a lot of the same DAX syntax and basic functions. That said, there are a number of very important differences and nuances between the two platforms, so I'd highly recommend working through each lecture of this course, even if you've recently taken my Power Query and Power Pivot course. And last but not least, we will not be covering Power BI Service as part of this course, so we're going to be focusing on Power BI Desktop specifically. Now, the online sharing and collaboration features on app.powerbi.com, those will be covered in depth in a completely separate course. With that, let's move on to the next section, Intro to Power BI Desktop. All right, hey there, I'm going to be checking in at the beginning of each section of the course just to keep a pulse on how our project's coming along. Now, before we dive in and really get our hands dirty, let's take a minute to talk through the Power BI interface and workflow. Let's make sure you've got the program downloaded and the right settings configured, and then I want to share some of my favorite resources that you can use if you need extra support along the way. All right, the time has come for us to officially meet Power BI. Now, a quick summary here. Power BI is a standalone Microsoft Business Intelligence product, which includes both desktop and web-based applications for loading, modeling, and visualizing data. Again, the focus for this course will be on desktop specifically. There's a ton of additional info if you'd like to learn more at powerbi.microsoft.com. Now, I want to show you something called the Gartner Magic Quadrant. And Gartner's a market intelligence research company. They produce these quadrants a few times a year. And what we're looking at here is the Magic Quadrant for analytics and business intelligence platforms specifically, updated February 2018. And the idea is that you have completeness of vision on the x-axis and ability to execute on the y. And when you break down the players into the four quadrants, you end up with niche players, challengers, leaders, and visionaries. And where you want to be is right here in this top right corner where the leaders live. And that's exactly where we find Microsoft with Power BI, leading the charge among some very popular, very powerful other platforms like Tableau, Domo, IBM, Qlik, etc. So really exciting time to be learning Power BI because I think it's only going to get more powerful and more popular from here. With that, let's transition into why Power BI. So what are some of the key benefits that make this such a game-changing product? Well, first and foremost, you can connect, transform, and analyze millions, even hundreds of millions of rows of data. And you can access that data from virtually anywhere, whether it's a database, flat files on your desktop, cloud services, folders of files, etc. There's a huge connector library that allows you to access a ton of information. And then not only that, but you can create fully automated and repeatable ETL procedures to shape and transform and load the data from those different sources. Next, we can actually build relational models inside of Power BI to blend the data from each of those multiple sources. And this is a concept that's getting more and more important in the analytics world. By creating relationships between all of those sources, we're able to analyze holistic performance across our entire data model. And that's a critical skill set for anyone working in data or analytics or business intelligence. It's that ability to blend information, tie sources together, and paint that comprehensive view of performance. Third, we can define complex calculations using data analysis expressions, or that DAX formula language. So we'll be doing this to enhance our data sets and enable some really interesting advanced analytics techniques using those powerful and portable expressions. And then perhaps the most important one, we can visualize our data with interactive reports and dashboards. And what we'll be doing throughout the course is actually building our own custom business intelligence tools using Power BI's best-in-class visualization and dashboard features. And then last but not least, fact is Power BI is the industry leader among BI platforms. It's intuitive, it's powerful, and most importantly, it's absolutely free to get started with Power BI Desktop. So again, really, really exciting time to be learning this tool. Now, last but not least, just want to make a quick comparison between Power BI and Power Excel, because there is quite a bit of overlap here, especially for those who have taken my Power Query, Power Pivot, and DAX course in Excel. So let's think of this like a Venn diagram, where you've got Power Excel tools on the left, you've got Power BI tools on the right, and this area of overlap in the middle with features that both platforms share. So here's kind of what it looks like in summary. You've got these Excel-specific tools on the left, like pivot tables, pivot charts, Power Map, Power View, and Cube functions. And then shifting over to the right side, you've got the report, dashboard views in Power BI that don't exist in Excel. You've got those custom visualization tools that we've been talking about, as well as the publishing and collaboration options available through Power BI Service. But where I want to really focus is this area of intersection. Like I've said before, these two tools are actually built on the exact same engine. Power BI takes the same data shaping, modeling, and analytics capabilities and then adds these incredible new reporting and visualization and publishing tools on top of them. So even though they're called different things in different places, the data loading tools will be called either Power Query or Get and Transform in Excel. The data modeling tools will be called Power Pivot in Excel versus the relationships view in Power BI. The fact is, it's all the same thing. And the best news of all is that transitioning is incredibly easy. These two platforms play really, really nicely together. So if you've been investing a ton of time building models in the Excel environment, no worries at all. You can import them right into Power BI in a matter of minutes. And I'll show you exactly what that looks like in the beginning of the next section. So there you have it. That's our intro to Power BI. Let's cover installing Power BI Desktop and adjusting settings for the purposes of this course. If you haven't already downloaded the program, it's a very simple process. Just head to powerbi.microsoft.com and click that sign up free button in the top right. That will take you to another page that should look something like this. You can click the download free button. That will actually start your Power BI Desktop download. Once the download is complete and you fire up the program for the first time, you'll likely see a screen that looks something like this. Now, it may ask you to sign in to collaborate and share content. Keep in mind that you don't have to sign in to use Power BI Desktop. In fact, you can click the Get Data button to get started, or simply close this screen and continue using Power BI Desktop as normal. The sign-in is only required to access the sharing and collaboration tools available through Power BI Service at app.powerbi.com. You absolutely can sign in or create an account. In fact, you'll get a free 60-day pro trial when you do, but it's not required for the purposes of this course. And keep in mind that if you do sign up for service, that Microsoft does require a work or a school email address. Next up, let's talk course options and settings. There are 3 different adjustments that we're going to make just to make sure that we're on the same page throughout the course. First, we're going to look at our preview features and make sure those are deselected. Now, as Microsoft rolls out new beta features and tools, those will populate in this list, and you have the option to enable them to try them out. In this case, we're going to deselect any of those and make sure that we're working from the same core platform. Second, we're going to update our data load settings to deselect the Auto Detect New Relationships option. And basically, Power BI, it's a very smart tool. When you load up raw data, it's actually going to analyze that data and look for relationships and say, okay, I've got a primary key here and a foreign key here. I think Chris is trying to create a relationship between these tables, and it will automatically add the relationship for me, which is great, but it's not so good when you want to demonstrate how and why to create certain types of table relationships. So for now, we're going to uncheck that option. And the third update we're going to make is with the regional settings. Now, this is an important one. We need to set the locale for import to English United States. And the reason we have to do that is that the downloadable resource files and the CSVs that I've created for the course projects are built using English settings. So the dates are formatted as month, day, year. We've got decimal places noted by periods, not commas. So if you're in an area with different regional settings, like Europe or South America, for instance, you might experience errors when you try to load up that raw data if your system is looking for a different format or syntax. So I'm going to open up Power BI right now and just show you these three options in the actual Power BI environment. All right, so here I am in Power BI. I'm going to go all the way up to the top left corner. This is kind of my home menu here. Options and settings, select options. And this is that dialog box that we're looking at. We're going to start with preview features. As you can see, we've got some shape maps, custom themes. These are kind of new features that Microsoft is testing or putting out as a beta trial before they roll it out into production. So just make sure these boxes are all unchecked as you're working through the course. Next up, we've got data load, and this is the box that we want to uncheck here, where it says auto detect new relationships after data is loaded. And again, that just makes sure we have a blank canvas to work with in our data model. And then finally, regional settings. Just drop down this list and choose English, United States, press OK, and you should be good to go. Let's talk about the Power BI interface and workflow. So when you open up a Power BI desktop file, it'll look something like this. We're going to dive into each of the specific menus and panes and options here as we move through the course. But what's important to pay attention to now is this set of three icons on the left side of the screen. These are your three core views that represent the entire Power BI universe. You've got your report view, your data view, and your relationships view. Now, when we think about the Power BI and broad business intelligence workflow, it actually doesn't really follow this order. We don't start with the report and then move into data, then relationships. We're going to follow kind of a different process. Instead, we're going to start with the data view and the query editor. This is where we're going to connect, shape, and transform that raw data. Once we have our data, we're going to shift gears into the relationships view. That's where we're going to actually design our data model and tie those tables together with relationships. And from there, we'll move into the third phase, which is actually designing interactive reports and visualizations, and all that's going to take place in the Reports tab. So we will be bouncing around quite a bit between all of these different views, but generally speaking, this is how things are going to flow. So let me pull up Power BI. Just want to give you a very quick preview of how these different views and tabs look and feel. So here we are in Power BI Desktop. As you can see on the left, we've got our three familiar icons: report, data, and relationships. Right now I'm in my report view, which is basically my canvas for creating dashboards. I can drag visualizations and objects. I can access my fields and measures here, but this is where all of the designing takes place. Clicking through to the data tab, this is where you can actually see the tables and the raw data and fields that you're working with. So you can click through to see different previews of your tables. You can also add your calculated columns and measures using data analysis expressions here as well. And then you've got your relationships view, which is all about the data model. This is where you can see your tables as objects, along with the relationships, the cardinality, the filter flow, everything about your model. And we're going to cover all that in the Data Modeling 101 section of the course. So there you have it. That's your 10,000-foot view of the Power BI desktop interface and workflow. Before we dive into the actual hands-on demos in Power BI, I thought it would be nice to share some of my most helpful resources. So first and foremost, right there within Power BI Desktop, you'll find a Help tab that contains a ton of great information. It's got links to documentation, to training videos, sample files, templates, support blogs, and communities, all accessible right there within the program, which is great. I'm also a big fan of the Microsoft Power BI blog. You can find this at powerbi.microsoft.com/blog. And one thing I like in particular is that they post monthly feature summaries. And this is a great way to see what Microsoft is rolling out, what new tools and features and functions are available in the updated version of the program. So I definitely recommend subscribing to that blog and checking it out. Next up, we've got the Microsoft Power BI YouTube channel. They publish some great demos. They also show the feature summaries here as well, and they've got some really good advanced tutorials. Also check out Guy in a Cube. It's another channel. It's sponsored by Microsoft. He does some really great advanced, more technical demos on his channel, which are really helpful. And then last but not least, Power BI user groups, or PUG. These are communities of users, including both local meetups and online forums. You can find them at pbiusergroup.com. This is another one I definitely recommend subscribing. They've got some great threads and forums where users can interact and help each other out. So go ahead and bookmark these, subscribe to the channels. I refer back to these resources all the time, so hopefully you'll find them helpful as well. All right, now before we move on, I want to take a few minutes and talk about a pretty big Microsoft update, which is the new Power BI ribbon. Now, important thing to note here, back in November 2019, Microsoft introduced a brand new redesigned ribbon experience for Power BI Desktop. Now, this was originally a preview feature, which meant that you had to activate or enable that feature in order to access it. But in March and April 2020, Microsoft rolled this out to general availability, which means that anyone using current versions of Power BI will see this new ribbon by default. So what does that mean? What's new here? Well, first of all, we've got a bunch of new contextual menus. And contextual menus are menus that only appear or get activated by specific user selections. So by selecting a visual, you'll access menus like the formatting menu or the data drill menu. By selecting items in your field list, you'll see table-specific tools, column tools, or measure tools. And this is great because it helps us organize those different specific categories of tools and only expose them when they're relevant or necessary. Next up, you'll see a much more consistent style and structure across all of the Office applications, including Excel, Word, and PowerPoint. Really nice to see that consistency, no matter which Office tool you're using. Third is that we have new accessibility tools. So Microsoft is introducing the same Alt key tip functionality that we've seen in Excel and PowerPoint right here into Power BI Desktop. You also have tab controls, basically options that help you access the tools you need without needing to use a mouse. And then last but not least, the final thing that I'll call out here is that we've got a bunch of new report themes and much more intuitive design previews. Now, if you open up Power BI Desktop and you don't see the new ribbon experience, open up your options menu and look for a checkbox that says Updated Ribbon. You may need to activate that depending on which specific version of Power BI Desktop you're using. And note that I've also included a link down at the bottom of the slide. This just goes out to the Microsoft documentation page where you'll learn a little bit more about the ribbon experience. Now, one thing I'll call out here is that most of you will find this new ribbon very, very intuitive. All the same tools are there. Most of them are in the same exact place. It just has a little bit of a different look and feel. But that said, I've actually made two pretty significant updates to the course since initially recording to help make sure people are following along as smoothly as possible. For one, I updated all of the slides in the PDF file for download to reflect the new current ribbon experience. And number two, anytime in the course demos where I'm accessing a tool that may have changed locations with this update, you'll see an overlay that looks something like this, which basically tells you where you can find that tool in the current version of Power BI. So anytime you see this, go ahead and pause your screen, make sure you're able to follow along, and hopefully that helps. Now, if I've missed any points or if you're still stuck at any points in time, go ahead and reach out to our team through the Q&A forum or the discussion board. We'd be happy to help make those updates. So last but not least, just want to give you a very quick tour through some of these new tabs. Keep in mind, these slides are really just designed to serve as a reference point that you can jump back to in case you get stuck, but I want to call out a few important things here. So on the report view, I'm going to walk through each of the tabs that you can access, starting with Home and Insert. Biggest change here is that the original tools that were all compressed into the Home tab in the old ribbon are now split across the Home tab and a new Insert menu. You'll see all the same stuff here, copy paste options, get data, data sources, refresh, new visuals, measures, all of that. Biggest changes that you'll find, in fact, probably the number one biggest point of confusion, is that edit queries is now called transform data. Does the exact same thing, launches the query editor, just changed the name. And on the Insert tab, you'll see kind of a new focus on these newer AI visuals, power apps, things like Q&A, key influencers, and decomposition trees. Really great new tools. If you haven't seen that AI section of the course yet, go ahead and check it out. Really great demos there. Next up, we've got the Modeling tab. Very, very similar. You can manage your relationships, add measures and tables here, parameters, view as roles. You've got the View tab. This is where you'll see some differences. Starting with those themes. You can define custom themes, and these previews make it much more intuitive to see how the look and feel of your report will change by selecting these different themes. You might also notice this Performance Analyzer button that's been kind of surfaced here in the new ribbon. This is out of scope of this course, but it's a great way to help you tune and optimize reports, see how long calculations take to run, visuals take to render, things like that. And then last but not least, you've got the Help tab, which is essentially identical to what you've seen in the past. Documentation, videos, links to support, blog and community, and so on. Now the asterisks here basically just tell you that these two tabs, Home and Help, can be found or accessible across every single view, report, data, and model. Now in the report view, you'll also see a couple different contextual menus, like the Format and Data Drill menus. And these are only going to appear when you have a visual selected. And inside of these menus, you're going to find the same old tools that you're used to seeing. You can access alignment tools, you can edit visual interactions, configure your drill down and drill through functionality. We'll talk about all that stuff later. Another thing to note here, you can access contextual menus like table tools, column tools, and measure tools right here in your report view as well by selecting items in your field list, which we're going to talk about next. So data view tabs. What are the contextual menus that you can access inside of your data view? Well, if we look at our field list here, first and foremost, if you select a table, you'll see a new menu called Table Tools. And as you might expect, this is where you can access things like table attributes, you can manage your relationships, add calculations and measures, and so on. When you select a column from your field list, you'll see a new menu specifically populated with column tools. You can access your column attributes, set data types and column formats, sorting and grouping tools here as well. And then last but not least, when you select a measure, you get your third contextual menu called the Measure Tools menu. And this is where you can determine which home table a measure is assigned to, set a measure format, add a data category, and so on and so forth. So again, quick pass through these menus. Keep these slides on hand as a reference, but hopefully you're able to follow along pretty smoothly. With that, let's go ahead and continue with the rest of the course. Okay, time to roll up our sleeves and actually load our data into Power BI. In this section, we're going to learn how to connect to our source files, shape and transform our tables, and use Power BI's query editing tools to modify, merge, and append our data. Now, make sure you follow along carefully with each step, because we're going to be using this data to build our data model in the next section of the course, and eventually our reports and dashboards. So let's get started. Let's kick things off and talk about data connectors, because Power BI has a really robust connector library that allows you to access data from virtually anywhere. So when you open up Power BI Desktop, you can click on this Get Data button in the Home tab to access the Get Data dialog box. And this is where you'll see all of the sources available to you. And bottom line, there's a lot. You can connect to just about any type of source data, including flat files, Excel workbooks, folders, databases like SQL, IBM, Azure, online services, which are more specialized like GitHub and Salesforce, or other sources like web feeds, R scripts, Hadoop, and so on. So tons of options for connecting to data. Now, I'm not going to speak to every single one of these, but let's fire up Power BI Desktop and I'll show you what this library looks like. Okay, so in this case, I've opened up a brand new instance of Power BI Desktop, and it takes me to this splash screen here. I can just close this out, or I can click Get Data right here on the left. Either way, I'm going to end up in the same place, which is the Get Data dialog box, which looks like this. And again, if you know you're looking for something specific, like a SQL source, you can use that search bar and kind of narrow down your results. Otherwise, you'll default to this all list, which shows you just about all of the connections available to you. Now, some of the interesting ones to call out, looking at the file options, these are pretty common ones, like text files, flat CSVs, contents from an Excel workbook. One of the interesting ones, which I'll show you a demo on later, is the folder. And this allows you to point Power BI to an entire folder containing files so that you can automatically append and blend new files as they're added to that folder over time. Really, really great automation technique, which again, I'll show you in just a bit. Database options kind of speak for themselves. You've got MySQL, Azure, IBM, all sorts of database options here. Online services has some interesting ones as well. Microsoft Exchange, Dynamics, and then some of the more specialized tools here, like Google Analytics, Adobe, Salesforce, Facebook, GitHub, and MailChimp. So definitely worth looking through the connectors that are available for you here. And then last but not least, in the Other tab, got some interesting ones in here as well. You can actually type in a web address to scrape data from a web source, or you could launch a blank query. And if you know how to write M code, you can generate a custom connection yourself. And we're actually going to do a simple demo using a blank query by creating a dynamic rolling calendar that updates based on the current date. And we'll cover that later in the section. So it's important to note that in this course, I'm not going to walk through these different types of connectors. And it's not because I'm lazy or because I don't want to. It's because the process is remarkably consistent and user-friendly across the board. So whether you're connecting to a database, a file, an online service, once you enter the specific information, maybe it's the server name and authentication for a database connection, for instance, once you get past that step, you always arrive at the same end result, which is the query editor. And that's where we're going to be spending most of our time. Now, for the purposes of the course and for ease of use, we're going to be using CSV files. Since they're simple, they're ubiquitous, you can download them straight from the course resources. But again, all of the concepts and tools that we cover in the query editor really apply to everything here, no matter the original source. So with that, let's move on and dive into the query editing interface. Now, when it comes to connecting and transforming data, the query editor is our cockpit. Now in Power BI, from the Home tab, you can click Edit Queries to launch the query editor. And there's a lot going on here. We're going to be spending most of our time in this section right here in the editor itself, but let's take a minute to break down the components of this interface. Right up there at the top, we've got our query editing toolbox. This is where we'll find all of the tools that we'll use to shape and transform our data. Right beneath that, you'll see a formula bar, and it's got some unfamiliar code in there. This is called M code, and I didn't write it. This is code that's automatically generated as you apply different procedures or steps to your table. For those of you who are advanced Excel users, this is exactly what VBA does, as it automatically generates Visual Basic code while you record a macro. Now, don't get nervous because you don't need to even know M code to use the query editor. In fact, we really won't be touching M code at all in this course. You can write custom M code from scratch, and you can edit the M code that's automatically generated for you, but you don't need to in order to use all of the tools that we're going to cover in this course. Now, on the left side of the query editor, we've got our queries or query list. Here you can see that I've got 9 individual connections or data queries in place. You can click through to see previews of your data. You can edit the properties, change the applied steps. Basically, any modification that you want to make to an existing query, you can do so here. And As you select individual queries, you'll see this data preview in the middle of the screen update. This is where we can spot check and QA our data and do things like change column types and headers. On the right side, we've got our properties pane. The most important thing to call out here is the table name. Now, it's really important to be strategic and clear with your table names right off the bat, because it can be a pretty big headache to change them later on, especially if you've already referenced them in multiple calculated fields and measures. So, rule of thumb, be strategic and careful about your table names from step 1. And then last but certainly not least, the applied steps pane here in the lower right. This is really powerful because what's happening here is that every time you make a change to your data, every time you apply some sort of shaping or transformation operator, Power BI will record an applied step using that M code and add it to the list here. And what that means is that every time this connection is refreshed, Power BI will run through that same set of applied steps to shape and transform your data. And that's a great way to automate things like data cleansing or ETL processes. You don't want to end up running the same processes manually over and over every time you connect to the data. This automates that process for you. You record it once, and then you're good to go moving forward. But perhaps the most helpful thing is that none of this is set in stone. You can click on the X next to any individual step to remove it. You can click through each of your applied steps to actually visually see the impact that it's having on your table, or you can click the gear icon on the right to modify or edit individual steps in the process. Now, moving on into the query editing tools, I want to take a minute to introduce the 3 primary tabs or categories. First, we've got our Home tab. This includes some general settings, data source settings, parameters, table properties, etc., as well as some of the most common table transformation tools. The next tab, Transform, includes additional tools that allow you to modify your existing columns. You can split or group columns, you can transpose your table, extract text, etc. And then finally, the Add Column tools actually create brand new columns in your table. And you can define those new columns based on things like conditional rules or text operations, calculations, date operators, etc. From here on out, we're going to jump into demo mode, actually get our hands dirty, and practice working with these tools. Got a lot to cover, so let's dive in. All right, so let's kick things off. Let's start nice and easy with table transformations. Now, if you go to the query editor, look in the Home tab, you'll see all sorts of basic table transformation options. Let's talk through some of the most important ones. First off, you can choose to keep or remove certain columns or rows from your table. There are a few interesting options here. Looking at the columns options, you can either select the column that you'd like to remove or select the column that you'd like to keep. Now, that might not seem like a really important distinction, but it can be really helpful in certain cases. So let's say you've got a data connection to a table that might have a variable number of columns. One month it might have 10, the next month it might have 20, but at the end of the day, you always want to land with the same set of 5 columns. If you were to open up the query editor and manually remove each of the columns that you don't want, then any new columns that appear won't be accounted for and will end up in your final table, which you don't want. On the other hand, if you select the 5 that you always want and you say, hey, Power BI, these are the 5 columns I need, anything else that you find in the table, remove it, then you'll be good to go moving forward. So it's a bit of a nuance, but actually a really helpful tool when you need to do something like that. As far as the rows are concerned, you've got some basic options here. Remove the top rows or bottom rows. You can set a specific number of rows to keep or remove. This is really helpful if you have files that might have header rows or footers or grand totals that you need to strip out. Other options here, you can remove alternate rows or you can remove duplicates. And that can be a great way to actually create new lookup tables from scratch by creating unique lists of IDs, for example. You'll also find some basic sorting options, A to Z, low to high, etc., as well as options to change your data types or promote your header rows. Now, Power BI is pretty smart about headers. By default, it should identify and promote those header rows for you, but in case it doesn't, you can always do that manually using this tool here. And then last thing to call out, if you right-click any column header, you can access a lot of these same common tools, plus do things like duplicate, move, or rename columns. And this is a common theme that we'll see time and time again as we work with the query editor, which is that the same tools are often available in multiple places, multiple menus, multiple tabs, sometimes even multiple views within the Power BI file. So with that, let's open up a brand new workbook and connect to our first data source. All right, so I've opened up a new blank Power BI file. Go ahead and do the same and make sure that you follow along carefully with what I'm about to demonstrate, because what we're doing is actually connecting to the source files that we're going to use to build our project throughout the course. So as you work through these demos and through the homework exercises, you'll be building up all of the pieces that we'll need to assemble into our final project by the end of the course. So let's get started by clicking on the Get Data dropdown. This allows me to access the most common options. In this case, we want a text or CSV file. And what I've done here is create a folder called Power BI Course Files on my desktop. And then within that, I've added a new folder called AdventureWorks. And this is where I've saved all 10 of those CSV files that are available for download as part of the course. So in this case, the file we want to work with first is AdventureWorks_products. So go ahead and double click to open that one up. Now, as soon as you've selected a file, the first view that you'll see is this preview window. And this has a couple options worth paying attention to. It will automatically detect the file origin as well as any delimiter in place. In this case, comma is correct since this is a CSV file. And then this data detection dropdown basically says, okay, do you want Power BI to take a little sneak peek at your data and take a guess at what these data types should be? If so, do you want it to base that guess on the first 200 rows? Do you want it to be based on the entire data set? Or should we not detect data types at all? In which case you can manually add those data types to your columns in the query editor. So by default, let's just keep it on the first 200 rows. Usually it does a pretty good job detecting the correct data types. And now from here, you can just load straight into your workbook. You can bypass the query editor entirely. As a best practice, I would recommend against doing that. Even if you don't think you'll need to make any sort of transformation to your data, launching the query editor is a great way to just QA and make sure things look good. So let's go ahead and hit Edit, which will open up the query editor. All right, so here we are. We're in our query editor. We've got our one lonely query here, AdventureWorks_product, which you can see has been named based on the file name itself. The same name has been applied to the table, AdventureWorks Products. And take a look at this. There are already 3 applied steps that have been made, and all we did was double click on the file. We haven't done anything else. So let's actually click back through and see what Power BI has done here. And if we expand this formula bar so we can see the M code, we'll get a sense of what's really going on here. So the first step, the source step, this will always happen. And this is just Power BI saying, okay, let's go find the file location and let's pull it in. In this case, we're looking at a path on my C drive, and it's finding the folder on my desktop and grabbing the AdventureWorks products CSV file. Now, I think this goes without saying, but your path will look different unless your name is also Chris and you've created the same exact file on your desktop. So that's step 1, the source, which makes sense. But look at the preview here. Notice how we've got these empty placeholder column headers, and then our first row contains the actual column headers. So the next applied step, as you may have guessed, identifies, it detects those headers and promotes them to the first row. And then from there, the third step looks like it's just changing some data types based on the detection that we talked about in the preview window. So jumping back and forth, you can see it's changed some text strings into whole numbers, numerical values, which looks good. So that's pretty cool. Power BI has already done quite a bit to help clean up this data set for us. And now from here, there are always 2 steps that I start with in the query editor. Every time I connect to data, every time I load up a table, I start with these 2 steps. Step 1 is updating my table name. So let's go ahead and select this and update it to AW_product_lookup. And I'll tell you more about why I'm using lookup in the table name once we get to the Data Modeling 101 section. But that should do the trick. AW product lookup. I can press enter to lock that in. And the second step that I always take in the query editor is to scroll through my column headers and make sure my data types and column headers look good. So let's go ahead and just collapse this formula bar. We've got product key, which is integers, got subcategory key, and then a whole bunch of text fields. Product SKU, name, model name, product description, the color, the size, the style, and then two more numerical fields here, the cost and the product price, which are decimal values. Now we could update these last two to currency or fixed decimal numbers, but I'm going to show you how to do that in a separate place later on, so don't worry about these two just yet. Now things look pretty good here. I don't really need to do much to this table at this point, it's pretty clean, but let's say we don't really want the product size column. It's kind of messy, we've got a mix of numerical sizes as well as text-based sizes like large, medium, small. So let's just remove this column. And like I mentioned on the slide, there are a couple ways to do it. I can either use the remove columns option here in the home tab, or I can right-click the column header itself and click remove. And when I do that, it's added a new applied step and removed that column. So that's just about all that I need to do here as far as transforming this table is concerned. If I wanted to, it looks like my product keys are sorted low to high, but if we wanted to make sure, we could go ahead and use the sorting options to do that here. And I think that just about does it. So we've applied some table transformations to our product table. We've given it a meaningful name, and we've confirmed that the data types and column headers look good. So all that's left to do is press this close and apply button, and it will go ahead and load it into our file. So now we can see on the right side in our fields list in the report view, we've got this AW product lookup table with all the fields listed out. You'll also see it in the data view. Here we go, the same table, same fields. And last but not least, it will appear as a new object right here in our relationships view as well. So congratulations, we just created our first data connection in our workbook. Why don't you go ahead and save this workbook. I'm going to call it AdventureWorks_report. You can name it whatever you want. And this is a Power BI file .pbix extension. Press save, and you are good to go. Next up, we've got text-specific tools. And looking at the Transform tab in the Query Editor, you'll notice that Power BI groups different sets of tools together based on their purpose or function. So in this case, we'll find all of our text-specific tools grouped together at the end of the ribbon. And within this group, we have some really interesting, powerful options. For one, we can split up a column based on a specific character or delimiter, or based on a number of characters. We can format any of our text columns using basic formatting options like lowercase, uppercase, propercase, which is capitalizing the first letter of each word, or we can use tools like trim, which eliminates leading and trailing spaces, or clean, which does the same thing and also eliminates non-printable characters. Now you might be thinking that those trim and clean options really aren't that helpful until you run into the case where you have one trailing space in your data set. And trust me, this will drive you crazy the first time you experience it until you figure it out. And the problem is, as human beings, we are incapable of seeing a trailing space. It's completely invisible to us, and it looks exactly the same as another data point without that trailing space. But to Excel, or in this case to Power BI, it looks like a completely different and unique value. So in cases like that, trim or clean can be great tools just to standardize and help avoid issues like that, especially if you're working with really messy or unstructured text data. We also have some great extract tools. We can extract a certain subset of characters from a string based on a specified length. We can extract the first or last number of characters or a range. But where it gets really interesting is using delimiters. So we can tell Power BI that we want to return all of the characters before a specific delimiter or symbol or character, or after it, or between two distinct delimiters. And there are also some advanced options as well that allow you to specify whether you search from the left side of the string or the right, and if you want to skip a certain number of instances of the delimiter before returning text. So some really great flexibility there with those extract tools. So you may have noticed that some of the tools here are grayed out and inactive, like merge columns or parse. And that brings up a really important point, which is that this toolbar is completely dynamic based on what you've selected. So if you've only selected a single column, the merge columns option is irrelevant, so you can't even click it. You'd have to select multiple columns in order to activate that option. And then taking that even further, if you've selected a column that's numerical instead of text, this entire group of tools might be replaced by number-specific tools instead. So just remember that the entire ribbon, the entire toolbar that you're seeing here will dynamically change based on your selections. Now, one more very important point before we shift gears into Power BI. Anytime you see this yellow box that says, hey, this is important, you guessed it, I'm about to talk about something important. So that means focus in, pay attention, stop playing with the dog or checking Facebook, because this is something that is going to come up time and time again in the course, and it's really, really important for you to fully grasp and understand. So what I want to talk about now is the difference between transform and add column, because this is something that confused me for longer than I care to admit. And what I was noticing was that the same tools, in fact, the same identical sets of tools, kept popping up in different places. And for the longest time, I just thought this was really confusing and redundant until I realized that the outcome is completely different depending on where you select that tool. So when you select a tool from within the Transform tab, you're essentially modifying or overwriting the column that you've selected. But when you choose a tool from the Add Column tab, you're creating a brand new column to your table. So that may sound really obvious when I say it now, but I guarantee as you're learning this tool and as you're playing around with the query editor, you will at some point in time select the tool from the wrong tab. And that's okay, because obviously nothing's set in stone. It's as simple as just deleting that last applied step and you're back where you started. But it is something to keep in mind, and hopefully that will help you at least understand where you're going wrong and why these tools appear in multiple places. So let's open up Power BI and get our hands dirty with some of these text tools. All right, so here I am in my AdventureWorks report. Go ahead and open it up as well. I'm gonna head back into the Get Data option, click Text CSV again. This time, instead of products, let's go into AdventureWorks Customers and double click. Here we've got our preview. All of these default settings look good. So I can go ahead and click Edit to launch the query editor. All right, so first things first, here's our AW product lookup query that we created in the last lecture. And now we see a second for AdventureWorks customer. So let's go through those two steps that we do every time we get in here to the query editor. We're going to start with the table name. And for the sake of consistency, let's go with AW underscore customer lookup. The last file that we loaded was called product lookup, and it was called product lookup for a reason, because it had all sorts of information about individual products, where each row represented a unique product key and each column represented some attribute about that product. Now, similarly, here we're looking at customer data instead. So I can press enter, lock in my table name, and as I look in the preview here, as you can see, I've got a customer key and then all sorts of attributes about my customers. So let's go ahead and finish our quick QA. We've got column headers that look correct. Let's look at the data values very quickly. Our key is a whole number, which is good. We've got names, which are strings or text fields, which are good. We've got a birth date column, which is a date, represented by this little calendar icon in the top left. And then as we scroll through, marital status, gender, email, all text. This one's interesting. It actually recognized the annual income field as a currency or fixed decimal. That's fine. We can leave it as is. And then we've got total children, education level, occupation, and a homeowner yes, no flag, all text. So check those boxes. Everything looks good. And now we can proceed to our table transformations. So first things first, let's scroll over. I've got my eye on these name columns because they're all uppercase and that looks silly to me. So I'd like to make those proper case instead. So let's go ahead and select the prefix column, go into add column. We'll find our text tools here. And what we want to do is go into the format tools and click capitalize each word, which is proper case. And when we do that, it created a new column here at the end of our table, which is essentially a duplicate version of our prefix column, but with the correct capitalization. And you can see that the header name has been defaulted to capitalize each word, which is just totally ridiculous. And as you probably have guessed by now, the reason this happened was because we accessed that format tool through the add column tab, when what we really wanted to do was simply overwrite the existing column and transform it. So we should have accessed the formatting tools through the transform tab instead. And so that's what I'm talking about. It's very easy to make these kind of mistakes. So you really just have to be vigilant about knowing which tab you're in each time you create a calculated column. But no worries, the good news is that it's a very easy fix. You can't Control Z to undo here. The equivalent is just going into your applied steps and pressing the X to remove that last step that we just created. So now I'll scroll back, select the prefix column again, make sure that I'm in my transform tab, and go through that same process. Format, capitalize each word, and there you go. It's overwritten the values into the format that I'd prefer. Now to do the same thing to the first and last name columns, I could do them individually, or I can select one, hold the Shift key, click the other. That will grab both of them at the same time. And let's do the 2-for-1 special. Capitalize each word. So now I have a nice clean prefix, first name, and last name. So that's helpful, but I'd really like to have the customer's full name accessible in a single field as well. So what that means is that I'd like to merge all three of these columns together and separate them with a space to create a brand new column that I'll name full name. So what I've done is select prefix, I've held Shift, selected last name to grab all three, and instead of clicking merge, warning signs, we're still in the transform tab. I need to make sure to go into add column instead and access the merge tool from here. So when I click merge columns, it gives me a little dialog box with some options. In this case, I do want a separator in between the values. I want that to be a space. And let's name our new column full name. So I'll press OK. And you can see it's added a new step. When I scroll to the right, there we go. We got our new full name column. Looks good. We've got spaces between the names. And now one thing to note, just kind of a side note, it added this step, but it kind of gave it a default name that says inserted merged column. Now, as I click through, it's pretty easy to see exactly what column was merged and what was added. But if we want to make this even more clear, I can always right click and rename that step. And instead of just saying inserted merged column, I can actually type full name. That just makes it a little bit more explicit what's going on. I inserted a new column and it's called full name. All right, so next up, I want to make a couple more changes. I want to really focus on this email address column here. And the first thing that I want to do is extract the username from this email. But the problem is I can't just say, give me the first 5 characters, because that would work for John 24, but not Eugene 10. So it's got to be a dynamic number of characters from the left side of this email address based on the location of that @ symbol. So this is where we're going to use that extract based on delimiter option. So let's go ahead and select email address. I want to add a new column for username. I'm going to use the extract tools here. So again, not just a default length, not an explicit number of characters, but I want the text before a delimiter. So here you go. All I need to do is say the delimiter that you're looking for is that @ sign. If we drill into the advanced options, this is where you can say, search from the left or search from the right. You can skip a certain number of instances of the delimiter. In this case, we don't need any of that. All we want is the text before the @ sign. So press OK, add in a new column. As you can see, it didn't let me name the column at the same time, but it did give me the values that I want. So what I can do here is just double click the column header and I can give it a name. Let's call it username. Now let's do one more similar example, but with one more complication. So going back to our email address, what if this time, instead of the username, we want to return the domain name? And the domain is anything that falls between the @ symbol and the .com at the end of the string. To do that, I can use the same extract tools, but this time I want the text between two delimiters. So I can go into this option here and I can say my start delimiter is the @ sign and my end delimiter is either the period, or I can type .com. Both will do the same thing. And when I press OK, same exact idea. It's given me a new column with the string or the characters between those two delimiters. I can change the column title to something like domain and press enter. And there you have it. So very, very easy way to do some pretty complex stuff. So one last adjustment to make to this domain column here. I want to get rid of the dash and replace it with a space. So to do that, I'm going to transform the existing column, not add a new one. And you'll see this other grouping of tools that say any column. That means they're not text or number or date specific. They can be applied in a number of different circumstances. In this case, I'll find the replace tool right here in this set. So it's as simple as it sounds. I can find the dash and I can replace it with a space, press OK. Now I've got adventure space works. And why don't we go ahead and format that capitalized in proper case, and we are all set. So there you go. We used the formatting options. We added columns, we transformed columns, we used the extract tools based on delimiters, we merged columns. Some really good examples of how these different text functions can be used to enhance and clean and transform a data table. So I think we're all good with customer lookup. The only thing left is to go back to our home tab and click close and apply to load that data into our file. And as soon as that loads up, we'll see that it's going to appear as another object right here in our relationships tab, right next to our friend product lookup. We'll also see it available in our field list, accessible in both the data view and the report view. So there you have it, query editing text tools. All right, moving right along. Next up, we have our number specific tools. So back to that transform tab in our query editor. Assuming we have a numerical column selected, you'll see a group of number specific tools active that look like this. And the first option within those number tools are the statistics functions. These are your aggregators like sum, min, max, median, average, standard deviation, and count distinct. Now you may be wondering, if you have a whole column selected and you apply an aggregation function that's designed to return a single value, how does that work? And I'll show you exactly how that works as soon as we jump into Power BI, but the answer is that these all return one value. So the entire table gets replaced with one single value. And as a result, you really don't use these statistics functions within the query editor as a means of transforming or preparing a table for loading, but rather as a way to explore it and maybe get some information about it. So the count of products, the maximum costs, the median age, questions like that. Now the next set of tools within this group, the standard, scientific, and trigonometry tools, these actually allow you to apply row level operations. So you can apply some standard operations like addition, multiplication, division, or some more advanced calculations like log, sine, tangent, etc. And these are actually applied to each value in a column. So unlike the statistics options, these tools are applied to each individual row in the table. So we're going to be using a ton of arccosine and arctangent throughout the course. Just kidding, we're not going to actually touch the trigonometry stuff. If you're looking to go deep into the trigonometry world, unfortunately, I'm not your guy. But that's neither here nor there. In addition to those standard, scientific, and trig functions, You also have your info functions, and these basically just allow you to define binary flags, either true false or 1 0, to mark each row in a column, whether it's even, odd, positive, or negative. So let's open up Power BI and practice some of these number tools. All right, so here we are in the AdventureWorks report. This time, instead of grabbing new data, I actually want to edit the product data that we've already connected to. So in that case, I'm going to go to my Edit Queries button. And that just jumps me straight to the query editor, where I'll see the two connections that I have in place, product lookup and customer lookup. You'll notice that all of the applied steps are still there, preserved. And in this case, I want to jump into product lookup and play with some of these number-specific functions. So if I jump to the Add Column tab, here are my number-specific tools. You'll notice that the statistics function is grayed out. And remember, because the statistics functions are aggregators, they're going to return a single value. So it doesn't make sense to add a new column that's derived by one of these stats functions. But when we move to the Transform tab, now you'll see the same set of number tools, and this statistics option will be active. And here you'll see all of those aggregation functions. So let's say we wanted to know the number of unique products captured in this lookup table. I could select the product name column, for instance, go into Transform, Statistics, and you can see that all of the options that require a numerical input, like sum, min, max, are grayed out. Since I'm selecting a text column, the only thing I can do here is count the values or count the distinct values. And in fact, all of my other number-specific tools are grayed out as well. So in this case, I want a distinct count of products. I can select that last option, and my whole table disappears and is replaced with that one aggregated value of 293. So what that tells me is that there are 293 unique product names in my product lookup table. And like I mentioned, as you can see, it's pretty obvious this isn't a means of transforming or preparing data for loading it into Power BI. It's more of an exploratory analysis. So almost every time you use these stats functions, you're going to go ahead and remove that last step to return back to where you started. So let's go through a couple other quick examples. I'm going to scroll all the way to the right to my product price column. And now in this case, I'm curious, what's the average product price in this AdventureWorks data set? So back to my Transform menu, the only place I can access my statistics tools, and I can drill in and calculate the average retail price, which is $714.44. Now that feels pretty high, but if we close back out, you'll see that we're dealing with cycling products, which include some pretty high ticket items like these road frames. And if we scroll over, you'll see that some of these are $1,200, $1,300. Some are even higher. In fact, we can go ahead and use another similar statistics function to answer that question precisely. Transform, statistics, maximum this time. And we see that the highest priced item, the maximum product price in the lookup table, is $3,578.27, which must be an extremely expensive bicycle. So there we go. We can X out, back to where we started. And let's test out just a couple more of these tools. Scroll back to our cost and price columns. This time I want to round these off to just 2 decimal places. So let's do it both at once. I can click product cost, hold shift, click price to grab both. And then I want to transform these columns. Don't want to add anything new. And I'm going to use the rounding tool this time. And what I can do is choose the third option, round, and say, let's round it to 2 decimal places. Press OK. Both those columns are transformed. Now both reflect just 2 decimal places, and we're good to go there. Now, one last thing I want to show you. I want to do a demonstration of the standard operations here. And so what I'm going to do is not transform this column, but I'm going to select the product price and add a new column using a standard operator. So what we're going to do in this example is we're going to add a multiplication step here. And what we'll do is multiply each value in our product price column by 0.9. In other words, I want to return 90% of the product price for each row. And this might make sense if AdventureWorks as a company, often ran 10% off deals. This might be something like a discount product price. So I can press OK. It's going to create a new column. By default, it gives the column header a name called multiplication. So let's double click and let's call that discount price and press enter. And just like we modified the product price and product cost columns, let's go into transform, rounding, and we're going to round this to 2 decimal places and press OK. And that looks good. So I think that's just about everything that we need to do as far as modifications to the product lookup table are concerned. So let's head to home. And now when we press close and apply, it basically just updates the query, loads the refresh table into our model. And there you have it. So nothing else has changed. We still see our tables here. This product lookup now reflects those new fields that we added, including discount price here at the bottom. So there you have it. That's your crash course in query editing number tools. All right, let's move on to date specific tools. Looking at the add column menu in our query editor, you'll see those date and time tools grouped here on the right. And these are actually pretty straightforward. We've got a few options here. One of the more interesting ones right at the top of the list is the age option. And that actually automatically calculates the difference between the current time based on the today or now function and the actual date in each row. You also have the date only tool, which basically looks at any fields that might contain both a date and a timestamp, and it strips the time component out and leaves you with just that date only. You also have your pretty basic set of date component functions like year, month, quarter, week, and day. And that basically just extracts individual components or individual attributes from a date field. And if you're selecting a field that has a timestamp as well, you also have similar time-specific options like hour, minute, and second. 2 other ones that I want to call out here, earliest and latest. You'll see those 2 at the bottom of the list, and they're both grayed out. And that's because we're in the add column menu, and both of those functions act just like the statistics tool, and they return a single value. So to access those 2 options, you'll need to grab them from the transform option. And as you might have guessed, the earliest option is going to return the earliest date in the column. Latest is going to return the last date. So quick note here, you'll almost always want to perform these date operations from the add column menu as opposed to transform, since most of the time the goal is to actually build out new fields using these date components as opposed to overwriting or transforming an individual date or time column. So pro tip here, what you can actually do in Power BI quite easily is load up a table that just contains a single set of dates, or you can create a date table and then use these date tools to actually build out an entire robust calendar. So that's exactly what I'm going to show you how to do in a second, but first let me give you a little peek of what that's going to look like. So we're going to start with a single column containing dates. We're going to apply those predefined date options using the add column tab in the query editor. And we're going to transform that individual column into an entire calendar containing additional fields like the day of the week, the day name, the start of the week, month, quarter, year, etc. So let's open up Power BI and give this a shot. All right, so if you're following along, go ahead and open up your AdventureWorks report file. You should see those 2 tables. We've got customer and product. We're going to go ahead and get data and grab a 3rd table from a CSV. And this time we want our AdventureWorks calendar table. So when you double click, preview looks very straightforward, just a single column containing our dates. Go ahead and click edit to launch the query editor. And here we are. So first 2 steps, table name first. Let's make it consistent, AW calendar. I could leave it here, but since this is technically a lookup table as well, I want to be consistent. So I'm going to add lookup at the end. So AW underscore calendar underscore lookup. Press enter. Obviously, the data type looks good, recognized and formatted as a date, and I've got a column header. So check, check, we're good to go. And now let's explore some of these date tools. And I want to actually start with the earliest and latest options. So I'm going to go to the transform menu, which again is the only place I can access these two options. And when I click earliest, it behaves just like those stats functions, transforms the entire table into a single aggregated value. In this case, it's one date, January 1st, 2015. That tells me that's the earliest date in my sample. So we can close that step, get back where we started, and repeat the process for the latest date, 6/30/2017. So that tells us that the scope of the data set that we're dealing with is from January 1st, 2015 through the end of June 2017, or about 2.5 years of daily data. So I'll X out of that applied step as well. And now let's shift gears into the Add Column tab. And this time I want to create some new fields based on this date. So as you can see, I've got all my options here. Let's start with a day option and choose name of day. So obviously that just created a brand new column, exactly like we'd expect, and it gave it a column header by default of day name. Now I can customize those headers. In this case, I'm okay with that, so I'll leave it as is. And now it's important to note when you use these date tools that you have to have your date column selected to access those tools. If I accidentally selected day name, for instance, which is really just a text string, and I access those tools, you'll see that now they're grayed out. You can't really do anything except parse that field since it's a text string. So I'll select my date again, and now I've got access to everything. So another interesting one I want to show you is week. And I want to do the start of the week here. And there you have it. As you can see, Power BI has decided that a week starts on Sunday. So January 4th, 2015 was a Sunday. The next week starts on January 11th, which was the next Sunday, and so on and so forth. You can actually change this, and it's not very intuitive. You actually have to dig in to the M code, which I told you we weren't going to do, but I lied. I want to show you this just because it's a really helpful little tip. And what you're going to do is I expanded the formula bar here, and you see where it says date.start of week and then the word date in brackets. I'm going to click my cursor right after the closing bracket and press a comma. Now there's two different ways to determine a custom start date for the week. Number one, I could type just a number, which Power BI will interpret as a day of the week. And I know for a fact that number 1 represents a Monday. So if I just type that 1 and press enter, now you'll see these dates all shifted by 1. So now the start of the week is on a Monday, the 5th, the 12th, the 19th, etc. You can go back in and press 2. You'll see they shift again to a Tuesday. So that's the first way to update. The second way, which is a little bit more readable, is to actually type day dot and then the name of the weekday. So day dot Monday, and there you go. I've got my Monday start weeks, January 5th, 12th, etc. So let's go ahead and leave it just like that, as is. I'll collapse my formula bar, and now remember, I have start of week selected. I'm going to go back and select date before I access these tools. And now let's go ahead and grab some month fields. So I want the start of the month, Jan 1, scroll down, Feb 1, looks good. Select date again. Let's go ahead and do the month name at the bottom here, name of month. There we go. And then we'll do 2 more for the years. I don't really need quarters in this case. So let's do the start of the year. And then the last one, let's do the actual year itself. So year. And that looks like a great start. I think that's pretty much all that I'll need. I've got date, the day name, the start of the week, start of the month, name of the month, start of the year, and the year itself. And so what this calendar table will allow me to do is filter and segment the values in my data set, in my data model, by any of these fields that I've just created. So it will allow me to look at things like sales not only by day, but by week or by month or by day of the week. And that's going to be really helpful as we start using more of these analysis and visualization tools. So our calendar is good to go. Let's click on our Home tab, press Close and Apply, and it will load it up into our model. And there you go, we have our third table accessible here. Let's check the relationships view. 3 table objects with all of those fields we just created based on that one single date column. And there you have it, query editing date tools. I want to share a pro tip with you guys that I think is pretty cool, and it's creating a rolling calendar. So in the case that we just walked through, we loaded up a discrete set of dates because we only wanted to analyze the data that we had on hand. In our particular case, we won't need to change that calendar. We won't need to pull in new data or analyze new information over time. But what if you're in a situation where you do? Maybe you've built a weekly report that you want to refresh with new data every week and share with your colleagues or your boss or your client. Rather than creating a fixed calendar and updating it over time, what we're going to do is actually use a little bit of M code. And I know this is the last bit of M that we're going to touch, but trust me, it's worth it. We're going to use that M code to create a calendar that will update based on the current point in time. So it will act as a rolling calendar that evolves as time goes on. So I'm going to lay out the steps here, and then we're going to jump into Power BI, and I'll demo what that looks like. So step 1, this is going to be a great time to test that blank query option that I showed you earlier. So we'll create a new blank query, and then in our formula bar, we're going to generate a starting date by entering something called a literal. And you're going to write it exactly like it's shown here, with a hash mark, the word date, and then a starting date, whatever you choose, in the year, month, date format. So in the example we're looking at here on the slide, this would represent January 1st, 2018. From there, you're going to click the FX icon, which adds a new custom step, and you're going to enter the following M formula. Now, I know it's a lot, and I'll post this function into the Q&A section as text so that you can copy and paste it, but we're not really going to dig in and unpack how this formula is working. We're just going to use it almost like a recipe to create our list of dates. So once you've added that formula, a list will populate in the query editor, and then we're going to convert that list into a table, and then we'll format that column as a date. Last but not least, if you want to, you can add some more calculated date columns, just like we showed with our last example. You can add years, months, week, whatever you need using those add column options, but it's really as simple as that. So let's hop into Power BI. I'm going to write out this formula, and I'll show you exactly how it works. All right, so I'm back in my AdventureWorks report. This time I'm going to go into the Get Data option, but instead of choosing CSV, I'm going to pick that blank query option down at the bottom. This takes me straight into the query editor and creates a new query just called Query 1. And if we wanted to, we could give this a name like rolling underscore calendar. Don't worry too much about this because I will be deleting this query after I write it. But just for the sake of habit, you'd want to give that a proper table name. And then inside of the formula bar, this is where we're going to type that formula that I just reviewed. So first step was to use the literal equals # or hash, date, open parenthesis, and then for the sake of example, let's use 2018, comma 1, comma 1. That will give us January 1st, 2018. And when we press enter, it just basically creates a single value, 1/1/2018. So that's not very helpful yet on its own, but it's a good starting point. The next step is to click this FX button to add a new step. And right here where it says equals source, this is where I'm going to type that long M formula that I shared with you. So follow along. I'm going to move kind of quickly, but go ahead and pause it once I enter the whole function so that you can make sure you've got it written down. So we're going to start with list.dates, open a parenthesis, source, comma, number dot from, open paren, date time dot local now, quick open and close paren, just like the now or today function in Excel. We're going to close out one more parenthesis, minus number dot from, open paren, source, close paren, comma, pound sign, duration, open paren, 1, comma, 0, comma, 0, comma, 0, and then 2 closed parentheses to end it. Now, without diving too deep into exactly what this M code is doing, in a nutshell, what we're saying is calculate the current date, compare that against the literal that we just created, which is our starting date, and then based on the difference between those two dates, I want you to list out all of the individual values where the duration is 1 day. So it's basically saying, give me a list at daily granularity between those dates, the literal and the current date based on today. So when we press enter, there we go. It created this whole list. And look at this. It starts at 1/1/2018. And as I scroll down through, it ends at 4/16, which is the current date. It's April 16th, 2018, as I'm recording this. And if we were to refresh this query a week from now, that end date would extend 7 more days. So we've essentially created this dynamic rolling list of dates. That was the hard part. Now all we need to do is click this new List Tools tab that popped up. And we're just going to click this button on the left to Table. And it basically converts it into a table. There's no delimiter. We shouldn't have any errors here, so we can just press OK. There we go. Final step is to format and name the column, and then we should be done. So go ahead and format as a date. Instead of column 1, you'd call it something like date. And now we've got a single column date table, just like we started with in the last demo. And from here, we could go ahead and add as many of those calendar fields as we wanted to. So really great tip that I use a lot in my own work. I manage a ton of reports that have to be updated very frequently, and this rolling calendar is a huge time saver for working with reports like that. So for the purposes of this course and this demo with our AdventureWorks data, we actually don't need the rolling calendar. We're going to rely on our AW calendar lookup table instead. So I know we just did all that work. We could keep the calendar here if we wanted to, or in this case, I'm just going to right click and delete that query. Really just want to focus on the one calendar table that we've got for the sake of this analysis. But there you go. Let's close out of the query editor and we're back to square one. So that's your pro tip, how to create a rolling calendar. Let's talk about 2 more types of columns that you can add from within the query editor: index columns and conditional columns. So starting with index columns, you'll find the option right here in the Add Column menu. And basically what an index column is, it's a list of sequential values that uniquely identify each individual row of a table. Typically these start from 0 or 1, and they're most often used to create unique keys or IDs that can be used to form relationships with other tables. And I know we've been kind of hinting at this idea quite a bit. That's going to be covered in depth in the Data Modeling 101 section of the course. So index columns, super simple. Moving on to conditional columns, these are a bit more interesting. You can find them right there above the index column option in the Add Column tab. And basically these allow you to define new fields based on logical rules or if-then conditions. So example that we're going to be walking through is creating a new conditional column that we're naming quantity type. And the way that we want to define quantity type is a function of the order quantity column. So we can tell Power BI for any row in our table where the order quantity equals 1, I want to set my quantity type equal to single item. If my order quantity is greater than 1, I want to set my quantity type to multiple items. And then you always have this kind of catch-all value if false otherwise statement at the end. That's basically the value that you want your column to take in the case that all of the rows or line items above are false. So Power BI is going to cycle through each row from top to bottom, and if none of those conditions are met, that otherwise statement is the value that's returned. So let's open up our AdventureWorks report and see what this looks like in Power BI. All right, so I'm looking at the relationships view. I see the 3 tables, 3 connections that we already have in place. We're going to go ahead and add a 4th now. So follow along. We're going to get more data from a CSV. And this time I want my AdventureWorks Sales 2017 file. And preview looks good. Let's go ahead and edit it to jump into the query editor. And right off the bat, let's simplify this table name a little bit. I'm just going to change this to AW Sales 2017. Now you'll notice that I'm not adding the word lookup to this table name, just like I did with product, customer, and calendar. And that's intentional because we're not dealing with a lookup table here. We're dealing with something called a data or a fact table. And we're going to explain what that means in the data modeling section of the course. But to give you a quick teaser, essentially we're looking at order quantities and order line items here with keys that will allow us to map those orders to territories, to customers, to products, and if I scroll all the way over, to dates. So no need to dive any deeper than that quite yet. Just put that in your back pocket because that will come into play in the next section of the course. So why don't we go ahead and practice adding an index column. So we'll add column, index, and if I drop down that menu, you can select to start from 0 or 1, or if you're feeling crazy, you can start with any custom number you choose. In this case, my keys or my ID columns typically start from 1, so we can choose that option. Creates a new column here at the end. Kind of interesting, it formatted it as a decimal number, which doesn't really matter, but let's go ahead and make it a whole number, just like the other columns here. And a little shortcut, instead of dragging it to the beginning of the table, you can right click, use this move option, and move it to the beginning just in one click. So there we go. Maybe this is something like an order ID that we want to use to kind of track each individual order, in which case we could rename the column. But to be honest, we don't need this ID or key column here. In fact, it may just complicate and confuse things down the road. So I'm actually going to right click and remove this column. Now what's interesting here is that I've landed basically exactly where I started. This is the table in its current untouched form, but you'll notice that there are now 7 steps in my applied steps here, because even though I removed my index column, that step was recorded and that step still exists here in the history of my applied steps. So what this means is that whenever this Sales 2017 connection is refreshed, Power BI is going to run through all of these applied steps. It's going to add an index column, change the type, move it to the beginning of the table, and then delete it, which is really inefficient and downright silly when you think about it. So rather than just calling it a day because I'm back at the correct table format, the proper approach here would be to actually remove all of those steps back to before I even added the index column in the first place. And now nothing's changed with my table preview. This is its original raw form, but now I only have 3 applied steps instead of 7. So kind of an important nuance to keep in mind there, and a good demonstration of how these applied steps are actually working. Now, last little demo, let's go ahead and add a conditional column right here above index. This opens up my dialog box, and we're going to name this column quantity type. And just like we talked about, we're going to say, okay, for every row in this table, if my order quantity equals a value of 1, then the output, or the value that my quantity type column should take, is single item. Just like that. Now I can press this button to add a new rule, and it gives me an else if line. So if this first row condition is not met, then what's the next thing you check for? Well, you check that order quantity is greater than 1, in which case my output, or my quantity type column, should equal multiple items. And you could keep adding conditions here if you had more complex scenarios. In this case, what we have here is a fully comprehensive and mutually exclusive list of conditions. We don't have any rows with an order quantity of 0, and I sure hope we don't have any rows with a quantity of negative values. So that just leaves us with 2 possible options. You've ordered one thing, or you've ordered more than one thing. But that said, as a best practice, kind of rule of thumb, I always put an otherwise value in here. So let's just say, if something's crazy, we get some weird data that we weren't anticipating, we'll just set quantity type to other and press OK. And there you go. You've got our new column, quantity type. You can see that it's taking values of either multiple or single item based on this order quantity column. And if we look at our header dropdown, one thing to call out here, it does show that the only two items or the only two options in this column are multiple items and single item. You'll often see this little flag that says list may be incomplete. That's just telling you that Power BI looked at a small sample of rows within that column in order to produce the list above. And that's just to save memory and processing power. But if you want Power BI to check the entire column to make sure that this list is comprehensive, just press the Load More button. And that flag goes away, and this confirms that this quantity type column that we just created contains two values, multiple items and single item. So press OK, and that's just about all we need to do. So let's go ahead and enter our Home tab and press Close and Apply. All right, let's save our workbook and keep moving on. Next up, I want to talk about grouping and aggregating data. So within the Transform tab of the query editor, you'll see this Group By option on the left, and this allows you to aggregate or roll up your data at different levels of granularity. So some common examples of this would be doing something like transforming daily transactions into weekly or monthly, or rolling up transaction level data by store, by product brand, by region, etc. So it's taking a really deep, really detailed table and rolling it up into a higher level summary. So let's take a quick look at an example. I know it's a little bit tough to see, but what we've got here are order quantities by order date, product key, and customer key. And the important thing to note here is that we have multiple orders for a given product key. In this case, product number 214 has been ordered multiple times on multiple dates by multiple different customers. And if you wanted to transform this table into a summary of orders, of order quantities, rolled up by unique product keys, the Group By option is a great way to do that. So when you click that Group By button, you'll see a dialog box that looks something like this, that basically allow you to tell Power BI, I'd like to group this table by unique product keys, and the operation that I'd like to evaluate for those product keys is the sum of the order quantity column. In other words, you're taking all of these duplicate rows with the same product key and multiple order quantities, and you're compressing them down to one. When you do that compression or that aggregation, how do we want to treat those order quantity values? In this case, we're taking a simple sum, and we're ending up with a table like this. Two columns, one containing unique, distinct product keys, and the second containing the total quantity or the sum of order quantity values associated with each. So to recap, what we've done is essentially transform a daily transaction level table into a summary of total quantity rolled up by product keys. And important thing to note here, as you may have noticed, any fields that aren't specified in our Group By settings are lost. They're not preserved in that final table because we eliminated that level of granularity in the process. Now, one more example using the Advanced option. Consider the same exact table that we started with. We're using the same Group By option, but this time looking at the Advanced version. And really the only difference here between Basic and Advanced is that Advanced allows you to specify multiple columns or additional columns to group by. So this time, instead of just grouping by product key, we're grouping by product key and customer key. And again, we're evaluating that same operation, the sum of the order quantity values, just like before. This time what we end up with is a 3-column table: product key, customer key, and total quantity. So to recap, we've again transformed that daily transaction level table now into a summary of total quantity aggregated by both product key and customer key. In other words, we're now looking at quantities by each unique combination of those two fields. So the best comparison that I can make, if you're an Excel user, this is just like creating a pivot table and pulling in the sum of order quantity into your values and your product key and customer fields into your row labels. So that's grouping and aggregating data in a nutshell. Let's actually work through an example or two in Power BI. So back in Power BI, I'm in my AdventureWorks report. Instead of adding new data, I'm going to edit my queries to jump into the query editor. Got my 4 connections, my 4 tables here. I'm going to dig into my AW Sales 2017 data, which contains daily sales records broken down by product keys, by customer keys, by territory keys. So this is a good candidate for using these grouping or aggregation tools. So just like our demo, let's go ahead and select the product key column. And let's say we want to turn this entire table, which contains multiple product keys and multiple instances of product keys, which we can see if we sort these. As you can see, multiple sales for product number 214, and so on and so forth for all of the other products in this table. There's a lot here, so we'll have to scroll quite a bit to get to them, but take my word for it. There are many, many more product IDs in here. So the idea is we want to take this table, collapse these rows with multiple product keys into essentially a summary table. And just like our example in the slide, let's evaluate the sum of order quantity for each of these product keys. So we can go ahead and transform, click group by. We're going to start with our basic option here, grouping by product key, the new column name, which is the column that contains the values that are getting aggregated or rolled up. We can call it whatever we want. Let's say total quantity, for example. And again, that operation, you have different statistical functions here, different aggregator functions. You could take the sum, you could average those order values, you could translate them all to a max or a min, you could count the rows. In this case, we want the sum, and we want the sum of that order quantity, and press OK. So just like our demo, this collapsed our data into a 2-column table with that new aggregated quantity field that we've named total quantity and a unique list of product keys. And I can test that they're unique by sorting them. And as you can see, there's only one instance of each of those IDs with the associated total quantity. Now let's do one more example. I'm just going to get back and remove those applied steps. And I want to do one more group by example with the advanced options instead. So let's select product key again, group by, click the advanced button, and now we can add a second grouping here for whatever other field we want to pull into this summary table. So in this case, maybe customer, maybe territory. I'm going to choose customer key here because I want to see the total sales for every combination of product and customer. And again, my column name could be something like total quantity, and it will be the sum of the order quantity. Press OK. And there you go. Very, very similar process here. It's now collapsed my table into a 3-column table containing unique combinations of product key and customer key. So there you have it. Once again, let's go ahead and remove those steps. We don't need the sort by product key. And then in fact, if we don't even want to save anything that we've done in here, we don't even need to go to the close and apply button. We can simply close out of that query editor. So there you go, grouping and aggregating data. Okay, so by this point, you should be pretty comfortable with the basic query editing tools, your date tools, your text tools, your number tools. And for the most part, they've all been pretty straightforward, pretty intuitive to use. But there are some pretty interesting, maybe not so intuitive tools available in the query editor as well. And one thing that I want to cover now is the idea of pivoting and unpivoting a table. So the way I describe it, pivoting is kind of just a fancy way to describe the process of turning distinct row values into columns, which is called pivoting, or turning columns into rows, which is called unpivoting. Now it sounds pretty simple, pretty straightforward on the surface, but it's actually a little bit tricky to get a hang of, at least it was for me. So I'm a visual learner, and what I'm about to show you is what finally caused it to click for me. So imagine this simple 2-column table. You've got years in the first column, and you've got a numerical field like unit sales in the second column. If we were to select the year column and pivot this table, we would essentially take the year in each row and turn it into its own column. So now instead of a row for 1994, we have a column for 1994. Same goes for 95, 96, 97, 98. So we've basically flipped that table from a vertical format up to a horizontal format. We've turned rows into columns. Now on the flip side, if we started out with the table in that horizontal format and we selected the years in the first row, we could unpivot to transform it into that vertical form. In other words, we take those years, which had been columns, and transform them into rows. So my little mental tip here is that I imagine that the table is kind of like on a hinge in that upper left corner. Pivoting is like rotating it up from vertical to horizontal, and unpivoting is like rotating it down from horizontal to vertical. Now, one thing to note, there's another tool in the query editor called transpose, and that works in a really similar way, but the difference is that it doesn't recognize unique values. So if you're dealing with a table like the one we're looking at here, where we don't have duplicate years or unit sales, pivoting and transposing would yield the exact same result. But if instead we had 2 rows of 1994, for instance, pivoting would collapse both of those rows into a single 1994 column, while transposing would preserve both versions and keep 2 separate columns, each with a 1994 header. So one way to think about it is that transpose is kind of clunkier, it's kind of brute force. It just takes the entire table and it just flips it on its side. So I actually have a little demo file that I'm going to show you, because you do have to really see this happening in real time to understand what's going on. So let me show you what that looks like. All right, so this file isn't available as part of the course resources, so just sit back and follow along for this one. I'm going to go ahead and grab my data as a CSV, and I've called this file unpivot demo. And I'm going to go ahead and open this up right here in the query editor. And right off the bat, you can tell this table is a little funky. There's some things wrong with this table. Number one, I don't have column headers, which is not that surprising. The column headers here are actually years. So when Power BI took a look at the sample of this table, it said, okay, you've got numerical values in each column. I have no way of knowing if that's a year or if it's a similar value to the one in row 2 or 3. It's an easy fix. You can just go ahead and click Use First Row as Headers. And there you go. Now our years have been promoted to headers. So we've made one improvement, but this table is still far from ideal. And what we have here is information about unit sales and revenue. We've got 2 different metrics broken down by year, 94, 95, each as columns. And as an analyst, as someone who needs to take this data and interpret it and analyze it and explore it, this type of table format can create a lot of headaches. Really what we're looking for here is a rectangular table with each dimension or metric as a column and each observation as a row. So ideally, what I want to transform this table into is a format that has 3 columns: year, sales, and revenue. That would give me a format that I could take and plug into my model and analyze in any way that I choose. So let's see if we can do that with our pivoting and unpivoting tools. Now, first things first, I don't like the fact that I have years in columns, so I want to turn these columns into rows. And to do that, I'm rotating down from horizontal to vertical or unpivoting. So what I can do is go ahead and select all of my year columns, go into transform, and then press this unpivot columns button. And there you go, it's transformed my year columns into year rows. It's labeled that column attribute, which is okay, we'll fix that later. And that hasn't totally solved my problem. I still have unit sales and total revenue as my rows instead of columns, but it's gotten me one step closer. And one thing to note before I move to the next step is that there's another way I could have done that. And let me just remove that step. And instead of selecting all 5 of these year columns, I could have selected this first column and chosen the unpivot other columns option. So you arrive at the exact same place, just another way to get there. So I've gotten a little bit closer. I've got values here, I've got years in a column. The only adjustment I need to make now is turn these unit sales and total revenue labels from rows into columns. So I need to do the reverse of what I just did and take this vertical orientation and pivot it up into a horizontal. So you guessed it, I'm going to select that first column, pivot the column, and this says, okay, where do your values live? Do they live in the attribute column or the value column? In this case, the value column. Press OK, and there you have it. So now we've got first column, which is attribute for year. We can go ahead and name that column year. We've got a unit sales column and a total revenue column. And this is a table format that I can work with as an analyst. So that was a great demo of how both pivot and unpivot can be used to kind of wrestle a messy table format into something more workable. Now, last quick demo here. If I take this all the way back to the start, just delete each of these steps, back to square one, because I'm not dealing with any duplicate values here, I could use transpose in this case as well. And in fact, that's actually a more efficient way to do this. I could select this entire table as is and essentially flip it or rotate it onto its side using that transpose option. So in the transform menu, I can just press transpose here, and that pretty much did the trick. It put years on a column, it put unit sales on a column, and it put revenue on the third column. The only thing we have to do now is use those first rows and promote the headers. And there you go. We've gotten to our same ending point using both combination of pivot and unpivot and transpose. So again, kind of tricky to work with at first, but these tools can be really, really helpful when you need them. So with that, I'm going to go ahead and delete that query that I just created. There we go. Close out of the editor. And there you have it, pivoting and unpivoting. All right, next on the agenda, we have merging queries. So you'll see the merge queries option in the home tab of the query editor. And when you click that button, it'll open up a dialog box like this, where you can select two tables and matching columns in order to create a merged table. And basically this works just like a VLOOKUP works in Excel. You're joining information from two different tables based on some common column or key. So in this example that we're looking at here, we're merging a table called AW sales data with another table called AW product lookup, both of which contain a matching product key column. So essentially what we'll be doing here is grabbing information or attributes about those product keys from the product lookup table and pulling them in or embedding them into our sales table by matching them to the associated product keys. So my trick for remembering this is that merging adds columns to an existing table. You're not adding any rows, you're pulling in more information and making your table wider by adding columns. So very important point here, just because you can merge tables and because it's an interesting tool to use, doesn't mean that you should. In fact, generally speaking, it's better to keep tables separate and define relationships between them within a data model. So more on that later, but keep that idea in the back of your head that you can merge queries like this, but it's not always the most efficient solution. So why don't we go ahead and jump into our query editor and I'll show you what one of these merges actually looks like. Okay, so I'm in the query editor of my AdventureWorks report, right where we left off. I've got my product table, customers, calendar, and my sales 2017 data. Now to demo the idea of merging, let's say that we want to look at our sales data, which has our quantities and our keys for territory, customer, and product. And let's say I want to pull a little bit of information about these products right here into my sales table without having to look at a product key and find that associated product key here in the product lookup table and get my information that way. Let's say I just want that information accessible in one place. I want to pull those columns right in there to the sales 2017 table. That's a case where you could use a tool like merge. So I'm going to start by selecting the sales table. I'm in my home tab all the way on the right. You'll see these merge and append options. We're going to talk about append next. But within merge, I can do it two different ways. I can merge or merge as new. And if I just simply merge queries, it will preserve the exact tables that I have in place now. It will just add the merged columns into my existing AW Sales 2017 table. If I choose the second option, it's going to create a brand new merged table that contains the merged result. while maintaining my original component tables as well. So I don't really need or want that option at this point. So I'm going to go with the first option, just merge queries. And what I see here is, all right, I've got my first table, the one I've selected, already populated here on the top half of the screen. And now it just says select a table and the matching columns to create this merge. So I can choose from one of my other queries or tables here. In this case, let's go with AW product lookup. Gives me a little preview here as well. And now the only column that actually matches here, if I look through these, is that product key column. So I'm going to go ahead and select product key in the product table, select it in the sales data, and I get this nice green check mark that says it's matched 29,481 out of the first 29,481 rows. So we've got a perfect match here, which is always good to see. So don't worry about the join kinds here. There are a few different options, different join types that you can choose from. The default left outer is typically the one you want. It's basically saying, take all the product keys that exist in my first table and grab any rows that find a match from my second table. And for our purposes, that will do the trick. So let's press OK. And you see what happens here? It added a column, but the column looks kind of funny. It says table, and it's formatted with these links. So there's one extra step we have to take here, which is to click this button here that actually expands the table out and converts it into the actual columns that I want. So by default, it selects all of the columns from the product table. If I pressed OK, it would pull in all 10 or 12 of these columns into my sales table. In this case, I don't want all of them. Let's just pull in the product key so that we can make sure we have a match, and maybe the product name and the color. And this last checkbox here just determines what the name of the column is going to look like. If I leave this selected, it's going to create a prefix for every column with the name of the product table, which for the sake of this example, that's fine. So when we press OK, it basically expands that temporary table column into the 3 columns that I had selected from the list, the product key, and again, it's got that prefix of the table name, the product name, and the product color. So if we scroll to our original product keys, we've got product 529, 214, scrolling to the right, 529, 214, you can see that it matched. And now we have this new information that hadn't existed in the sales table up to this point about the product name and about the product color. And this populated for every single row in our table, just like a VLOOKUP would have in Excel. So like I hinted at earlier, just because we can do things like this and merge our tables together doesn't mean we always should. In fact, merging information in the way that we just did actually creates a lot of duplicative and redundant data, which can be avoided entirely using table relationships instead. So again, we're getting there soon, but for now, let's go ahead and delete that merge that we just did, and we're back to where we started. So there's a quick demo for how to merge queries. All right, next up we've got appending queries, and you'll find that append queries tool right under merge in the home tab of the query editor. When you click that button, you'll see a really simple dialog box like this, where you can choose to append either 2 tables or 3 or more. Now both merging and appending are similar in that they're adding information to an existing table, but they're different in that merging is adding columns and appending is stacking rows. So basically, appending queries allows you to combine or stack 2 tables, assuming they share the exact same column structure and data types. So keep that in mind, same structure, same data types. So in this case that we're looking at here, we're appending 2 tables together. They're 2 different AdventureWorks sales tables, one from 2015, one from 2016, and it's a valid append since they both share identical table structures. So just like we talked about, merging makes tables wider by adding more columns. Appending makes tables taller by adding more rows. Now, pro tip here that I want to share with you, which we'll actually dive into with the demo in the next lecture, is to use the folder option from the Get Data menu. And what that lets you do is actually point Power BI to a folder containing as many files as you choose, which allows you to append all of them at once, assuming they share that same structure. And the beauty of it is that over time, if you add new files or remove files, simply refreshing that query, that connection, will automatically append any new data that's shown up within that folder. So it's a really powerful option that we'll dive into in the next video. But for now, let's cover the basic append option and shift gears into Power BI so we can take a look. Okay, so I'm here in the query editor. I'm inside of my AW Sales 2017 table. And because I've got 4 different tables here, each with a different column structure, there's nothing that I can really use to append with what I've got on hand. So I know that I'm going to need to grab some new data. I can do that right from the editor by clicking New Source, Text CSV, and I want to grab my other 2 AdventureWorks sales files. So let's grab 2016 first. Let's see the preview, and we can press OK to load straight into the editor. And why don't we update the table name while we're thinking of it, AW Sales 2016, and we'll repeat that process, New Source, CSV, for the 2015 file. Press OK from the preview, AW Sales 2015. Okay, so now we've got 3 separate AW Sales files, all of which are consistent in terms of the columns. There's 2015, 2016, with one exception in 2017, which is that new quantity type column that we added when we practiced that conditional column tool. So one option would be to go ahead and continue to append these together. You'll see some null values for the quantity types in the other 2 tables, and you could pretty easily redefine that conditional column to the full appended version. In this case, we're not going to be using this column for anything, so let's go ahead and just remove it. There we go. And now we've got a perfectly consistent table structure across all 3. So now with one of them selected, it doesn't matter which one, I'm going to start with 2017. In my Home tab, let's go to Append Queries. And this time, instead of the first option, we've got that same choice that we had with Merge, where we can either append within the existing table or as a brand new table. This time, let's try the new table. So when I click that button, this time we have more than 2 tables to append. We have 3 or more, and it's automatically populated the first one that I've selected. So the only other 2 that I need are Sales 2016 and Sales 2015. So we can go ahead and press OK, and it creates a new table. It names it Append 1 by default. Let's go ahead and change that to something like AW underscore sales underscore 2015 through 2017, just to be clear. And now we can look through the column structures, look exactly as we'd expect. Same column structure as each component table. And now when we sort these order dates, let's sort them ascending. We see that the table now starts on January 1st, 2015. And if we expand and load more to see the full list, we can actually scroll all the way down and see that it takes us all the way to the end of June 2017 with 2016 dates in between. So we've got dates from all 3 of those sales tables. So that's great. We've successfully appended the sales data from our 3 individual tables into one appended version. But one downside of this approach is that now that I've got the table that I want with all of the data in one place, let's say I want to get rid of these older individual tables just because they're taking up space. If I right click and try to delete the 2015 query, it won't let me because it's being referenced by another query that appended 25 through 2017 table that we just created. So the problem here is that our new table, our 2015 through 2017 table, is dependent on the other 3. So we have to kind of keep all 4 of them here, which is okay. There's nothing wrong with that. It's not going to create any big problems. It just feels a little bit messy. So one way around that, which I very much recommend, is to move these files into a folder and then connect to the folder itself. So stay tuned because in the next video, I'm going to show you exactly how to do that. All right, so I just showed you how to stack some tables together using the query editing append tools. We took these 3 individual AdventureWorks sales files from 2015, 16, and 17, and we appended them as a new table called AW Sales 2015 through 2017, which included all of the data across all 3 files. And that worked pretty well, but remember the downside. This new table that we created is now dependent on the 3 individual component tables. So we can't delete any of these individual tables. We have to keep this whole set of 4. So let's actually scrap these 4 sales files and pull them into Power BI using the folder approach instead. So I can delete the appended file first, and press OK. And once that one's gone, now I can delete any of these individual ones because no relationship between them exists and there are no more dependencies that we need to worry about. So 2017, delete. There we go. So all of our sales data is gone. We're left with just the product lookup, the customer lookup, and the calendar lookup. And what I'm actually going to do here is pull up the folder on my desktop containing these individual CSV files and create a new folder there. So go ahead and pull up your folder as well. Okay, so here's where I've got all of my AdventureWorks CSV files, including the 3 individual sales files. What I'm going to do is actually right-click and create a new folder right here within this same AdventureWorks folder, and I'm going to name it something like AW_sales. You can name it whatever you want. And then once I've created that empty folder, I'm going to select each of my sales tables, 2015, 16, and 17. I'm going to drag them all into that AW sales folder. Now when you click in, you can see that it contains all 3 of those files. And once I've done that, I can go ahead and close that file window, return back to my query editor, and I'm going to go ahead and grab a connection to a new source. And this time I need to go down into the More options. And right here on the right, you'll see the option to connect to a folder. So let's go ahead and connect. And the first thing that Power BI is going to ask for is the folder path. So let's go ahead and browse and navigate to those course files, Power BI course files, AdventureWorks, AW sales. So that's the folder that I just created that contains those 3 individual sales files. And I can go ahead and press OK and OK once more. Now the preview window looks a little bit different. It has this column that says content binary. It's got file names and extensions. So rather than actually previewing the data, the actual rows and columns, it's previewing the files that exist within this folder path. Now we have 2 options here. We can either combine and edit on the spot, or we can edit and actually walk through each of the steps of the combination. So I'm actually going to choose the edit option because I want to show you exactly what this looks like bit by bit. So there we go. When I press edit, it lands me here in the query editor, and I see that similar kind of view that I got in the preview, right? I'm not looking at actual data points. I'm looking at attributes about the files that exist in the folder that I've linked to. So the key here is to look at this first column. This is kind of similar to the column that was created when we merged tables, where we had to take one extra step to actually split out the columns from the table itself. Same idea here. We have to take one extra step to break out the actual content within these CSV files located in the folder. And to do that, we'll just press this Combine Files button right here in the Content column header. And when we do that, it runs through the append process and opens up a new preview window with a Combine Files header. And this shows us an actual data preview from each of our files. We can select the first, the second, or the third here. And if our preview looks good, if we know we've got the same column structure, data types, which we know we do, then we can go ahead and press OK. And after it runs through some processing, you'll see that the data lands right here in the preview window and contains data from all 3 of our files. So same thing, we can filter on that order date, show more. We're starting in January 2015, and our dates extend all the way through 2016 through the end of June 2017. So we've got all of our data in here, got all of our familiar columns out to the order quantity column. We do have one additional column here, which is the source name, and that just tells us which file within the folder that data came from. So kind of a helpful attribute if you do want to keep it. In this case, we don't need it. So let's go ahead and remove that source name column. And there you have it. We have our appended table containing all of our sales data in one place. And as you can see, it automatically gave us a table name based on the way we named our folder, which in this case was AW_sales. We can either leave it just like that or add the years to that, 2015 through 2017. In this case, I think this is the final version of the sales table that I'm going to use. So in this case, AW sales, it's nice, it's clean, it's concise. That'll work just fine. So last thing to note, over here on the left side of the screen, you'll see that AW sales table showed up right beneath our calendar lookup. You'll also see some automatically generated query information above that. And this was all automatically written, automatically generated in order to make all that magic happen by appending the files within the folder. So we don't even have to touch this. We don't even have to think about this. I usually will just kind of collapse it. And then in this other queries folder, this is where all of our kind of primary tables will continue to live. So again, same end result as loading up 3 individual tables and using the append tools from the home menu, except now we have one nice clean table without those extra tables and dependencies. And even more importantly, if we ever needed to pull in additional years of sales data, we could simply drop those CSV folders right into that AW sales folder and press refresh right here inside the query editor, and all of that data would automatically be pulled in. So that should just about do it. Last step is to close and apply. And that'll go ahead and load that new AW sales data to our file. And let's take a look at relationships. There it is, AW sales. So with that, there's your pro tip, connecting Power BI to a folder of files. Okay, so up to this point, we've talked about a number of the most important data transformation tools in the query editor. Next up, to round out the section, I want to cover some important settings and options. And the first topic is data source settings. So in the home tab of the query editor, you'll see this option for data source settings. And that basically just allows you to view and manage all of the individual connections in your Power BI file. So in this example that we're looking at here, we've got connections to a number of individual CSV files, as well as a folder down there at the bottom of the list. Now, the critical concept to understand about data source settings is that when you make a connection to a local file, a file that's located on your computer, Power BI will basically take a snapshot of that exact file path to that exact file name. And what that means is that if anything changes about your file, if you rename it or if you move it to a new location, that path won't automatically update. So what you need to do is go into these data source settings, click Change Source, and browse to the revised version of that file. So this is probably the most common issue that I see in Power BI. People inadvertently rename a file or rearrange things on their desktop and accidentally break these file paths. But the good news is that it's a very easy fix as soon as you understand how these data source settings work. So let me show you what I mean. So I'm here in the AdventureWorks report. I've got my 4 tables at this point, including that AW sales table that's now linked to the folder that we created in the last video. And you can either follow along with me here, or you can just watch, because we're not actually going to be adding new data or revising anything that we have. I'm just going to show you a demo of what happens when a file path does break in the way that we talked about. So I'm going to edit queries to open up the editor. And as you can see, all 4 of my tables look good. And when I drill into the data source settings button right here in the home tab, I can see these 4 connections in place, my 3 individual CSV files, calendar, customers, products, and then that folder that we just created. So everything looks good, everything's running smoothly. But now what if I accidentally changed one of those file names? So let me navigate to my actual source folder on my desktop. There we go. Here are my AdventureWorks CSV files that I'm pointing to. And as you can see from my query list, one of those files is the products file. So let's say I accidentally rename this file products2 or something similar. Now when I minimize this window and return back to the query editor, when I click the product lookup query and click this refresh preview tab, as you can see, I get this error that says we couldn't find the file. And if you read closely, you'll see why. It's because it's looking for the file with its original file name and location, AdventureWorks_products, not products2. So the issue goes all the way back to the very first step, which is the source. And again, it's because Power BI recorded or locked in the exact file path when I first created that connection. So I have two options to fix this here. Option one is simply to rename that file and remove the 2 that I added at the end. Option two is to drill into my data source settings, find the trouble spot, in this case the products line, click change source, and simply browse to the updated version, which lives right here, AdventureWorks Products 2, press open and OK. And now when I close this data source settings window, go back to product lookup and refresh once more, now we're back to usual. So the source populated properly, all of those applied steps are maintained, we didn't lose any information, and we're back right where we started. So pretty simple fix. We could leave things just like they are, or to kind of show you the same process in reverse, what I'm going to do is change that file name back to its original form. So I'll go to my desktop folder and then simply remove that 2 at the end of the file name, close that window, go into data source settings, products 2, change the source, and again browse back to the original named AdventureWorks_products. Press OK, close out the settings window, and if I refresh, there we go. Everything looks good. So we haven't actually made any changes, but hopefully that was a helpful demo for how to address those data source errors using the data source settings options. Next up, I want to take just a second to talk about refreshing queries. Now, in the Home tab of your Power BI file, outside of the query editor, you'll see this refresh button across all of your views. And by default, when you press that button, it's going to refresh every single query, every connection, every table that exists in your model by default. But you can customize these refresh options. So within the query editor, in that queries pane, you can actually right-click any one of your individual connections or tables, and you can simply deselect or uncheck that box that says include in report refresh. And as you might expect, that prevents that file from refreshing whenever you hit that refresh command from the Home tab. So helpful pro tip here, what you can do is exclude all of your queries that don't change often or don't change at all, like your lookup tables or any static data tables that you might have. So let's go ahead and open up the query editor and make some of these adjustments ourselves. All right, so here I am back in my query editor. I see my 4 queries or connections here. And when I right click each one of these, you'll see that include in report refresh line, and I see a checkbox, which means that each one of these tables, product, customer, calendar, and sales, will all refresh with the report. And in fact, if I just go back to my relationships view here and press refresh, you'll see all 4 of these tables are evaluating, processing, refreshing. So essentially Power BI is going to those source paths and refreshing the data in the CSV, even if nothing has changed. So there you go. It's just refreshed all 4 tables. Now let's hop back into the query editor. And what I want to do here is actually prevent my 3 lookup tables from refreshing when I hit that command. because at least for the time being, I'm not going to be adding information about products, about customers. I won't need to add more dates to my calendar. But just for the sake of example, let's keep AW sales as is. So let's allow the sales data to refresh. So I can simply right click and click that include in report refresh option, which just deselected it. I'm going to do the same thing for customer and the same thing for calendar. And now when I close and apply and press refresh again, only that AW sales table was loaded. And you see that it worked a lot more quickly that time. That's because we're not refreshing 3 queries that aren't including any more data. It's just redundant, it's a little bit inefficient and slow. So again, good rule of thumb, if you have data that's static, if you have tables that aren't going to be changing, go ahead and exclude those from the report refresh and only refresh the ones that may be changing over time. So we've already seen some options for formatting or changing data types within the query editor. We've formatted columns as dates, as whole numbers, as currency and decimals. But there are some additional options that we'll find outside of the query editor in the data view, specifically the modeling tab, that will help us not only define more specific data formats, like specific date or currency types, but also categories. And many of these categories that you see here are geographical in nature. They capture things like addresses, cities, latitudes, longitudes, etc. The purpose here is that categorizing your data in this way, especially geospatial data, helps Power BI accurately map and visualize those location-based fields, those things like addresses, countries, continents, zip codes, etc. So let's head back to our AdventureWorks report, and I'm going to show you a couple examples of how we can do this. All right, this is one that you're going to need to follow along closely with because we're going to be modifying some of our data formats and adding a new table or a new connection to our file. So first and foremost, let's head to our data view, which we haven't really spent much time here yet. And within this view, you can see previews of your tables. Here are my 4 tables on the right side of the screen. You can drill into different individual fields as well. Now, looking at the calendar table, you'll note that the dates have defaulted to this long form format. And there's nothing wrong with that. It's still correct. I would just prefer a shorter, more concise format. So when I select the column, these formatting options within my modeling tab now become available. So the data type is set to a date, which was established within the query editor, but now I have more specific formatting options. So under the date time menu, I actually like this first option, month, day, year. This is kind of the classic standard English US format. So I'll just click that and it will refresh and basically overwrite that long form and format it in that new kind of shorter form date format. I'm going to go ahead and do the exact same thing to my start of week column as well, start of month, and start of year. So that just kind of cleaned things up a little bit. I also have a date field in my sales table. In fact, I have 2 date fields, the order date and the stock date. So let's go ahead and just select each one of these and format in that same short form date. And now one other adjustment with the data that we already have. If we jump into our product lookup table and scroll to the right, remember we hadn't really been able to format those currencies exactly how we wanted to in the query editor. So same idea here. We've got the data type, decimal number. We can actually format as a specific type of currency. So many more options here than we had within the query editor itself. So I'm going to choose the dollar sign in English format. And there you go. Repeat the process for product price and then for discount price as well. There we go. Now these are nice and clean, properly formatted US currency fields. Now, last item I want to address here is this data category field. And this is what I showed you in that slide with those geospatial fields. You've got other kind of categorizations like web URL, even barcodes and image URLs. So to show you how that works, I actually want to connect to a new table. So we can go to Home, Get Data, Text CSV, and this time the field that I want, the table that I want, is AdventureWorks Territories. So we'll double click, fire up the preview pane, default looks good, edit it in the query editor. And as you can see, pretty simple table here, only about 10 rows. We've got sales territory keys, and each key is associated with a given region, country, and continent. So this is going to help us understand for those sales in our AW sales data, where are they coming from? What countries, what regions, which continents are driving the most sales? And help us kind of answer questions like that. So first things first, you know the drill. Let's change this table name to AW_territories. And you guessed it, this is a lookup table. So AW territories lookup, press enter. We've got proper headers. Our key is a whole number. Everything else is text, so that looks good. Go ahead and close and apply. And now as you can see, we've got this new table that's popped up here at the bottom of our field list in the data view. And just to save space, I'm going to collapse these other tables and drill into that territory lookup. And there you go. That looks nice and familiar. So last step here, we will want to visualize some of this data using the map tools and visualizations, which are really, really handy in the report view. So to make sure that Power BI is visualizing things properly, let's go ahead and use those categorization options in the modeling tab. So we'll start with country, select the column, and under the data category dropdown, be careful you don't click county because that's different from country. I've made that mistake before. You want country/region. And then for continent, you've got a continent option as well. And because these regions are kind of custom defined, Northwest, Germany, UK, they don't really follow a standardized mapping syntax. We're okay with just categorizing country and continent for now. And important note here, Power BI will almost always recognize these fields properly by default automatically. So had we not gone through this step and just plugged these countries into a map visual, 99.9% of the time it's going to work exactly as you'd expect and you'd get accurate results. But as a best practice, it really couldn't hurt to explicitly define what types of data categories you're working with. And last thing to note here, see these little icons to the left of the fields. You'll see a bunch of different types, and we'll talk about what these mean. But the two little globe icons indicate that these have been categorized as geographical fields. So a nice little helpful visual cue there. So let's return to our relationships view. See that territories table object pop up. Now we've got 5 connections here in our report. Let's go ahead and give it a save and keep cruising ahead. Next up, I want to touch upon one other option available in the Data tab of Power BI, which is the ability to define hierarchies. Now, hierarchies are essentially groups of columns that you nest underneath each other to reflect multiple levels of granularity or detail. So for example, a common type of hierarchy is a geographical one, and that might include columns like country, followed by state, followed by city. And note that they become more granular, more specific and detailed with each level of the hierarchy. So what's nice about these is that they can actually be treated as a single item in your tables and reports so that users can view the data at the highest level and then drill up or drill down through the different levels of detail in a meaningful way. So one example here is creating a hierarchy with date fields. So what you'd actually do in the data view is drill into your calendar table and you'd right click a field, in this case start of year, and select the new hierarchy option from the menu. Now what that does is it creates a brand new field. It doesn't overwrite the existing ones, it creates a brand new one that now contains start of year. And I'll show you what this looks like, but it shows you a very clear icon that indicates this isn't just a regular field, this is a hierarchy that we're dealing with. So then from there, right click any other fields that you'd like to add, like start of month or start of week or date, for instance. And instead of clicking new hierarchy, you're going to click add to hierarchy. and select the date hierarchy or whatever you've named it that has already been created. So this is the method to actually build one of these hierarchies within the data view. So one thing to note here is that I know I'm showing you a hierarchy example with date fields specifically, but Power BI is actually very, very smart about dates. And in fact, it will create a lot of date-related hierarchies for you automatically without having to manually create a set like you see here. But there are other examples where that's not the case, where Power BI won't automatically recognize fields in a hierarchical way, in which case building a set like this is very helpful. So I'm going to show you an example of that right now. Let's head back to our AdventureWorks report, and I'll show you what I mean. All right, so once you've opened up your AdventureWorks report file, you should see the 5 table connections that we have in place. Let's jump into the data view. And for the sake of example here, we're going to create a very simple hierarchy using these territory fields. And this is a good candidate to use here because we've got 3 different fields kind of in descending order of detail or granularity. Continent is the broadest category, followed by country, followed by region. So let's go ahead and start with continent, right-click, create new hierarchy. As you can see, it maintains or preserves that original continent field and adds this new line item with this little icon that indicates that there are subfields within it. In other words, this is a hierarchy, and it's named it by default continent hierarchy since that was the field that I had originally selected. So you can right-click and rename it, and I'm going to call it something like, oops, kind of in the way there, something like territory hierarchy. Okay, so it shifted things around since it's alphabetical order here, and put that territory hierarchy there at the bottom. So the 2 other fields that I want to add to this are country and region. So I can select country, right click, and add it to that territory hierarchy. Same goes with region, right click, add. Now it's just nested each of those fields under continent and created this hierarchy containing 3 different levels. If you added them in the incorrect order, like continent, region, country, you can simply click and drag to reorder them around. So now to recap, once we get into the report view and start visualizing things, building charts and graphs, instead of pulling in 3 individual fields for continent, country, and region, we could pull this single hierarchy object into the visual and allow users to drill up or down to these different levels of detail. So a really interesting tool, great way to add more depth to a Power BI report. All right, time to share one of my favorite pro tips, importing entire models directly from Excel. So in Power BI, we've got this import menu that we haven't really talked about with the option to import Excel workbook contents. And note, this is different from using the Get Data option and pointing to an Excel workbook. This is actually importing additional information about an entire model from Excel into Power BI. So what's incredibly helpful about this is that this import process preserves just about all of the information about your model. It transitions information about the data source connections and queries that are in place, all the file paths. It maintains the query editing procedures, all of the applied steps, the data modeling details like the relationships, hierarchies, field settings and formats, etc. And then last but not least, all of the calculated columns and calculated DAX measures that you've added to your model in Excel. So quick pro tip here, Power Pivot in Excel does actually include some features, some really helpful features that Power BI does not. So some additional filtering options, a little bit more of a user-friendly DAX interface, for example. But the fact is, if you're more comfortable building models in the Excel environment, which is covered in my Power Query, Power Pivot, and DAX course, then go ahead and continue to build there within that environment, and then import those models into Power BI for the reporting and visualization phase. You'll end up at the exact same place. It's really just which environment you're more comfortable in. So sit back, relax for a minute, just watch this demo. I'm going to show you what this looks like when you actually import a full data model from Excel into Power BI. All right, so I actually want to start in Excel for this one. This is my Food Mart data model complete file, which is probably bringing back some flashbacks to students who were in my last course. And basically we've got a data model here with a bunch of lookup and data tables. Got a diagram view, which, there we go, should show us all of the relationships in place. We've got parameters and disconnected tables as well. So it's a pretty robust model. And on top of that, if I manage my measures, we've got all of these DAX measures that we created, which would be a huge headache to have to recreate from scratch in Power BI. Luckily, I won't have to. Now, one thing to note here, I also have these additional pivot tabs with things like conditional formatting and data bars and icon sets. Now, there is no equivalent pivot view quite like this in Power BI. There's a matrix visual that's similar but not quite the same. So these views, these actual pivots, these additional tabs will not transfer over. So I just want to caveat that. So from here, I'm going to open up a blank, brand new Power BI file so that I can import this model directly into it. So here we go, blank file, untitled. And now again, instead of going to get data from Excel, I'm going to choose this top left main menu and import Excel workbook contents. Big difference here. And when I do that, I can navigate to my FoodMart data model complete file. It gives me this little note that says, hey, we don't work directly with Excel workbooks, but what we can do is extract the content so that you can use it right here in Power BI Desktop. And so I read this, I'm like, all right, that sounds great. Let's go ahead and start the process. And we get an error, which is pretty straightforward. It says, oh, we can't do it right now because your model is open in Excel. So easy fix. Let's go ahead and close the Excel version. Don't need to save any changes. And let's go ahead and retry that. There we go. So now it says, okay, we've got some tables that exist in that original workbook. In other words, they were created with actual cell ranges in Excel. And it just says, do you want to copy the data and create a version right here in the Power BI desktop environment, or keep this remote connection back to the Excel workbook, which sounds like kind of a nightmare. So I'm going to say, let's take the data from that price threshold and age threshold table, and let's copy it so that it exists here as well. And now it runs through all these fancy things. That was real time. That was about, I don't know, 5 or 10 seconds. And check it out. It's migrated all of these items, different queries, different data model tables, all these KPIs and measures. And when we press close, obviously there's nothing in our report view because there's no equivalent to the report view in Excel. But if we go to data, check it out. All of our tables exist here. All of our fields, including all of these calculated measures. I think there's a bunch here in my transactions table. Yeah, they've all carried through all of our measures. In the relationships view, we can see that our data model with all of its table relationships is still intact. It got a little bit scrambled, so it doesn't look quite as nice and clean, but we can go ahead and just rearrange things as we see fit. So some of these details aren't really going to make sense quite yet until we dive into the data modeling and the DAX sections of the course, but I wanted to just give you a little preview and let you know that there is this option to pull a fully baked model from Excel straight into Power BI. All right, everyone, time to take this section to the finish line with some best practices for connecting and shaping data. Now, number one, get yourself organized before even loading any data into Power BI. So I've said it before and I'll say it again, defining those clear and intuitive table names right from the start will save you a ton of time in the future. Updating table names can be a big headache down the road, especially if you've already referenced them in multiple places, like DAX measures. One other side note here, I'd recommend not using spaces in your table names. If you do, it just means you've got to surround that table reference with single quotes every time that you reference them. Now, second, highly recommend establishing a clear and organized file and folder structure that makes sense from the start. This will help you avoid having to go in and modify your data source settings anytime those file names or locations change. Number two, I'd recommend disabling report refresh for any static sources in your model. And at the end of the day, there's no need to constantly refresh those sources that don't update frequently, or in some cases at all, like lookups or static data tables. So you really only need to enable refresh for tables that you expect to change over time. And last but not least, when you're working with larger tables or models, only load up the data that you need. So there's no point including hourly data when you only need daily, or product level sales or transactions when you only care about performance at the store level. So keep in mind, this can be changed over time. Nothing's set in stone, but at the end of the day, extra data is only going to slow you down. So there you have it. We've officially wrapped up our entire section on connecting and shaping data, which is the first major phase of the business intelligence workflow. So congratulations, but keep in mind that we're really just getting started and we've got some great stuff ahead. Next up, we'll shift gears into creating table relationships and building custom models within Power BI. Stay tuned. All right, time for the homework solution walkthrough for the connecting and shaping data assignment. Now, important comment here, if you didn't complete the homework, I'd highly recommend that you go back and do so, or at the very least, follow along closely with the solution that I'm about to walk you through, because we're actually going to be adding new fields and new tables that will be critical for the rest of the course. So with that, let's get started. Question 1 asks us to create 2 new queries to the product categories and product subcategories CSV files from the course resources. Then once we load those, we're going to name them consistently with our other tables, AW product category lookup and AW product subcategory lookup, and go through and make sure that the headers look good and the data types are correct. So let's go ahead and start with the category file. I'm going to get data from a CSV, and I'm going to find AdventureWorks product categories, and that's the one I'm going to start with here. I'm going to edit to launch the query editor. I'm going to change this one a bit to AW product category underscore lookup. Again, just for consistency with all of our other table names. Press enter. Looks like my headers have been promoted properly. I've got a key, which is a whole number, consistent with my other tables. That looks good. And I've got a category name as a text field. So I'm good to go with this table. And from right here within the query editor, I'm going to grab my second table, which is the subcategories table. Okay. And same idea here. AW product subcategory lookup. Pretty simple, pretty small table. Headers are promoted. I've got my key as a whole number, which looks good. I've got my subcategory name, mountain bikes, road bikes, etc. That looks good as a text field. And I've got an additional key here, also formatted as a whole number for product category. So all looks good here as well. I can check that box. And now the last thing I need to do for question 1 is disable report refresh for both of these new connections. So product subcategory, just deselect that report refresh. Same with category. And now I'll just double check both of these. Should not refresh when we use that command from the Power BI file. So there you have it. Question 1 is complete. Moving on to question 2, we need to make some modifications to the AW product lookup table. And the first thing we need to do is add a calculated column that extracts characters before the dash in the product SKU column. So this is our product SKU column. You can see we've got some text characters, dash, some numbers, another dash. And essentially what we want to do is create a calculated column. We want to name it SKU type, and the value that we want that new column to take would be the characters before that first dash. So to do that, we're going to add a column, and from our text tools, we're going to extract text before a delimiter, and that delimiter is the dash. So we can press OK. And as you can see, it added that field. It extracted the 2 characters before the dash. You can go ahead and double click the column header and name that SKU type. And there you have it. Now the next question actually asks us to modify that calculation that we just made. Now we want to pull all of the characters before the second dash. So to do that, let's go back to that step, press the gear to edit it. And we're going to go into our advanced options. And we're still going to start from the left, or the start of the input, but we're going to skip that first delimiter, that first instance of the dash. And we press OK. We can go ahead and scroll back to that calculated column. and now it contains those first characters as well as the first dash and those characters before the second. So we can go ahead and click through to keep that renamed column step, and now we've got that updated SKU type column, which pulls in all of the text from that product SKU column before the second dash. Next up, we need to replace zeros in the product style column. So here's our product style column. Let's see what we're working with here. We've got the zeros, and then we've got M for men, U for unisex, W for women's. So just check that out, press OK. Now what we want to do here is not add a column, but transform this existing one. And we're going to use the replace values option and simply find the 0 and replace it with NA. Press OK. You can see those swap in. And when we drill back in, now we have same 4 values except that the 0 has been replaced by that NA. Now the final part of question 2 is to update the discount price calculation from 10% to 15%, which means we'll need to multiply that product price value by 0.85 instead of 0.9. So let's jump back to the step where we calculated that discount price, which is this step right here, inserted multiplication. We can press the gear icon, and all we need to do is update that 0.9 to 0.85 and press OK. And there you go, it's updated the raw values here. And now we can click through the additional steps. You don't have to do it one by one, but I kind of like to see the history and take us to the end. So now we've updated that discount price column from 90% to 85. And that wraps up question 2. So now moving to question 3, we're going to practice using those statistics tools in the transform menu. So there are a few values that we need to validate here. First one is the average product cost. So we can stay right here in our product lookup table, select the product cost column, make sure we're in the transform menu, go into our statistics tools, and select average. That returns a value of $413.66, which checks out. And now for each of these transformation steps, I'm just going to end up deselecting that step to take me back to where I started. And let's move on to the next one. So number of distinct product colors. Let's scroll through. Here's our product color category, and we want the count distinct from this column. So transform, statistics. Note that we only have our 2 count options because this is a text field, and we want count distinct. That gives us 10. So we've got 10 different distinct product colors that we're dealing with here. Next up, we need the number of distinct customer names, which means we need to move to our customer lookup table. And let's go ahead and find that full name column that we had created. Here it is, full name, transform, statistics, count distinct, 18,110 distinct customer names in our lookup table. So that one checks out as well. And then we've got a couple more, maximum annual customer income. Here's our annual income column, transform, statistics, maximum. That translates to $170,000, which is correct. And then 2 more, we need the count of order numbers and the count of distinct order numbers. So for those, we need to go into our sales table. And we've got our order number column right here. And you guessed it, transform, statistics, count values. Got 56,046. And if we undo, select order number again, transform, statistics, count distinct, we get 25,164. So the difference there means that there are duplicate values in the order number column, which might seem weird at first because we feel like one row should represent each order. The difference is that we have this order line item column. So there may be a single order with multiple line items, in which case one order ID might show up twice with an order line item of 1 in the first row and 2 in the second. Okay, so that's all of question 3. We validated all of those numbers. Now let's move on to question 4, which is making a few modifications back in that customer lookup table. So number 1, we need to add a new calculated column for the year of birth we're going to name it birth year based on the birth date column. So here's birth date, add a new column. We use the date tools for this one. And all we want to do is just extract the year out of that birth date. And there you go. All we need to do is double click, rename that column header to birth year. Simple enough. Now, last but not least, we're going to practice a conditional column. And what we're looking to do here is create a new column named income level based on criteria from the customer income column. So let's go ahead and select that income column. There it is. We're going to add a column. We're going to add a conditional column. And the column will be named income level. So we can start there. And then we're checking conditions against that annual income column. So the first criteria is if that annual income is greater than or equal to $150,000, then the output, the value that we want our new income level field to take, is very high. Now, if this condition is not met, what's the next condition that we want to test for? So the next condition, the else if condition, is if annual income is greater than or equal to 100,000, in which case income level equals high. And then the third condition is if annual income is greater than or equal to 50,000, then the income level equals average. And then we don't have to add another explicit condition for less than 50 because that's kind of the only other option here. So we can go ahead and account for that condition here in the otherwise statement and say if none of these conditions are met, if a customer in a given row didn't make more than 150,000, they didn't make more than 100, and they didn't make more than 50, then the label that we want to assign them is an income level of low. And that should just about do it. Let's press OK. There we go. It added that new column called income level. And if we drill into the header, load more, as you can see, we've got values populating throughout the whole range: low, average, high, and very high. So there you go. That's all the table transformations and modifications that we need to make. All of the edits that we just made in one go can be applied by going to the Home tab, close and apply. It's going to go ahead and factor in everything we've just done. And you'll see two new tables pop up in your relationship view: product category, product subcategory. You'll also find them in the fields list, category and subcategory here in the data view. And then if we drill into our customer table, you'll see that calculated income level field that we just created in the query editor. So that wraps up the homework assignment. Hopefully you were able to follow along. I'd recommend that you go ahead and save a backup version of this report somewhere else on your machine, just to have on hand in case anything happens. But with that, we're ready to move on to the next section. All right, great work so far. We've got all of our source data connected and loaded into Power BI. The goal of this next phase is to create table relationships so that we can blend all of this information together within a single normalized data model. We've got a lot to cover, so let's get started. All right, so to kick off this entire section about creating data models, I figured it would only be appropriate to start with a simple question. What exactly is a data model? Now consider a relationships view that looks like this. We've got three different tables here: a product lookup table and two data tables, sales and returns. This alone is not a data model. What we're looking at here is a collection of independent tables which share no connections or relationships. So think of each of these tables as its own little island with no idea that the other two even exist in the model. And what that means is that if you were to try to do something like this, breaking down a field from the sales data, like order quantity, or a field from the returns table, like return quantity, and break those quantities down by a field from the product lookup table, you're going to get the same grand total in every single row of the table. And again, that's because both the sales and the returns data tables have no idea that there even is a product lookup table that exists in the universe, let alone how to break down those quantity values by individual product names. So if this is not a data model, then what is? Well, let's consider that same structure, that same relationships view, except now we have relationships connecting the tables together. This is a data model. And again, it's a data model because the tables are now connected via relationships based on a common field or key, which in this case is the product key column. And without diving into the specifics just yet, what this means is that if we revisit that same analysis, looking at order quantity and return quantity by product names, now we see the correct values, because now the sales data table knows that the product lookup table exists. In fact, it's connected to that product table based on the fact that they share a common product key. And the same story holds for the returns data and its relationship to the product lookup. So as a result, we're able to take any field from the product lookup table and filter and segment values from those two data tables. Now you'll see that same familiar grand total row at the bottom, but now we get accurate numbers for each individual product. So this is obviously a relatively simple example, but it's this core concept of joining and blending our data together using table relationships and common keys that will be the focal point of this entire section of the course. And it's this core concept that's going to enable us to do some really interesting, really sophisticated analyses. So let's shift gears, open up our AdventureWorks file. I want to show you what this looks like in the Power BI environment. All right, so once you've opened up the AdventureWorks report file, you're going to want to make sure that you're using the latest version after the homework assignment from the last section. So you should see a product category and a product subcategory table. We're going to go into the report view now for the first time. And there's going to be an entire deep dive section covering all of these visualization and reporting tools. But for now, we're going to use one type of visual in particular called the matrix, which looks like this. And the matrix acts kind of like a pivot table. You can analyze values from a numerical field and break those values down by dimensions placed in rows or columns. So in this case, our values are going to come from our AW sales table, specifically the order quantity field. So let's click and drag that order quantity to values, and you'll see the total quantity from that column populate here in the matrix, 84,174. Now, if we want to break down this quantity or analyze it in a more detailed way, our only option is to use fields that exist within this same sales table. So product keys, for instance, can be placed on the rows, and now we see those order quantities broken down at the product key level. So that's all well and good, but we're extremely limited by the scope of that table. And to show you what I mean, let's go ahead and remove that product key. Let's go into the product table itself, which contains all sorts of interesting information about those products: the price, the name, the description, the color. And let's say we want to break down those quantities by product name. When we drag that field into rows, we get that same grand total over and over and over and over and over again, which is the exact same issue that we saw earlier on the slide. The sales table has no idea that a product lookup table even exists. As a result, it has no way to break down those quantity values based on any field in the product table. So this limitation is exactly why we need to build out a data model, and exactly why we're going to spend so much time learning how to do that in this section of the course. So stay tuned, more to come. All right, time to talk about something really, really important called normalization. Now, this is a tricky one to wrap your head around at first, so I'd encourage you to rewatch this video as many times as it takes until it starts to really stick. So by definition, normalization is the process of organizing the tables and columns in a relational database to reduce redundancy and preserve data integrity. So a lot of fancy words there, kind of tough to understand what that really means, but basically it's used to do three different things. Number one, eliminate redundant data, which helps to decrease table sizes and, more importantly, reduce processing speed and improve efficiency. Number two, helps us minimize errors and anomalies when we make data modifications. So if we need to insert or update or delete records in our database. And number 3, it helps simplify queries and structure the database in a way that enables meaningful, useful analysis. So still feels kind of overcomplicated if you ask me. So my tip to remember what normalization is all about is to think of it this way. In a properly normalized database, every table should serve a distinct and specific purpose. So you might have one table that only gives you information about products. You might have another that only gives you information about dates, like a calendar table. You might have one that's only daily transactional records, and another that's only about customers. Now, this should sound pretty familiar because these are the exact type of tables that we're using here in this AdventureWorks demo. So let me take a stab at visualizing why normalization is such an important concept. Consider a table like this. You've got transaction quantities here in the third column, broken down by product ID and by date, as well as all of this extra information about each product ID, the brand, the name, the SKU, and the weight. And as you can see just from this small sample, that we have multiple transactions or multiple quantity values per day and multiple quantity values per product ID. So this table is not normalized. It doesn't serve a single unique purpose. It's actually serving at least two purposes. One, providing the transaction quantity by date and product ID, and 2, providing additional attributes about those products. Those are two different purposes. So what you end up with here are all of these duplicate rows in any case where the same product ID appears more than once. So you see duplicate brand names, product names, duplicate SKUs and product weights. And you might be wondering, okay, that's not that big a deal. I'm still getting the information that I need. In fact, I have it all in one place in a single table, which is great, so I don't see the downside here. Well, imagine if we were dealing with 100 different products, and each of those products, on average, sold 10,000 times a day. Now all of a sudden you're talking about 1 million duplicate rows for every single date in the data set. So you can see that with larger or more complex models, minor inefficiencies like this can become major problems as you scale up in size. So the way to avoid issues like this is to strip those product attribute columns out of this table and create a relationship with a single product lookup. And if that product lookup contains a unique list of product IDs with those associated attributes, then we can access the exact same information here while eliminating every one of those duplicate rows. So again, this concept may still feel a little bit ambiguous, but trust me, we're going to get our hands dirty. We're going to do a ton of demos, walk through a bunch of samples, and this is going to start to feel much more natural as we continue through this section of the course. So next up, we're going to talk about data tables and lookup tables as our first step towards building a properly normalized model. All right, continuing on with this concept of normalization, let's talk about data tables versus lookup tables. Now, generally speaking, data models contain two different types of tables. Data, sometimes known as fact tables, and lookup or dimension tables. And the way to kind of differentiate between the two is that data tables contain those quantitative metrics, the numbers or values that you really care about. Typically, these data tables are pretty granular and detailed level with ID or key columns that can be used to create table relationships to lookups. Now, on the other hand, lookup tables, they provide descriptive, often text-based attributes or characteristics about each dimension in a table. So you remember in the last lecture, I talked about each table in a model serving a specific and distinct purpose. Well, that's exactly what lookup tables are doing. They're providing rich information and attributes about things like customers, like products, like dates. And that's exactly the role that they play within our model. So let's walk through an example here. This blue table is a data table. It contains numerical values, those quantities, along with two key columns that we can use to connect this data table with some lookups, a date column and a product ID column. So what we'll be able to do is take that date column and connect it to a date column within a calendar lookup table. And the entire purpose of the calendar lookup table, its entire reason for existing, is to provide additional information about each date. So it's got one row per date and additional attributes like the day of the month number, the year, the weekday, and so on and so forth. So the bottom line is that if you know the date, you also know all of this additional information about months, quarters, years, weeks, etc. And the calendar lookup provides or gives us access to that information. Same story holds for the product ID. That product ID column in our data table can connect to or relate to a matching product ID in a product lookup table. And that product lookup table's purpose is to provide all sorts of product specific information about each ID. So similar concept to the calendar table, just in this case, if you know the product ID, then by definition, you know the brand, you know the product name, you know the SKU, the retail price, the cost, the weight, and any other product specific attributes captured by this product lookup table. So in order to understand the real mechanics of how these relationships work, one of the first things we need to dig into is the idea of primary versus foreign keys. Now consider the same set of three tables: our blue data table, our green calendar, and our orange product lookup table. Consider the date and product ID columns in our data table. These are called foreign keys. They're keys because they're used to create relationships with our lookup tables, and they're foreign because they contain multiple instances of each value. And this is the case with many data tables. Here we have multiple transactions and multiple quantity values per day, and multiple transactions and quantity values per product ID. So we could potentially see many duplicate values in both of those date and product ID columns. Now when we look at the same columns in the lookup tables, date in the calendar table and product ID in the product lookup table, these are called primary keys because they uniquely identify each row of the table and they match the foreign keys in any related data tables. So it's easy to mix these up, but as a rule of thumb, primary keys are unique, foreign keys often contain duplicates. So let's jump into Power BI. I want to open up the relationships view and see if we can identify some of these primary and foreign keys in the AdventureWorks tables that we're working with. Alrighty, so once you've got your file open, we're going to go ahead and navigate to the relationships view. And we're going to be spending a lot of time here because this is where the data modeling magic really happens. And the first thing I want to do is just looking at these tables that we've got, I want to identify which are data tables and which are lookup tables. Now we've already started hinting at this quite a bit. We know that the one table that contains our quantitative metrics, the values that we care about, the order quantities, is our AW sales table. So let's grab that. I'm just going to pull it down to kind of distinguish it from the lookup tables. So now we know this is our data table. Looking up at our other tables, product lookup contains all sorts of information about products. Customer is all obviously focused on customer level information. Calendar is all about dates. Territory has information about sales regions, countries, and continents. And then we have some additional product related category and subcategory tables that are almost getting orphaned off here. So come on back, guys. So all of these tables serve very specific, distinct purposes. And I'm kind of an OCD person, so I'm going to drag the product lookup table over here with its friends and click and drag and just rearrange things a bit. We're going to be doing more designing in here, but there we go. So at this point, we know which tables are lookup tables, and we know which table is our data table. Let's take a quick pass through and see if we can identify our primary and foreign keys. So starting with our lookups, customer lookup clearly has a customer key that uniquely identifies each row within this table, and therefore uniquely identifies all of this information about customers. Calendar lookup, same story here. It's not called a key, but the date serves that purpose. If you know the date, you know all of this information about that date, the month, the week, the day of the week, and so on and so forth. Territories, we've got a clear sales territory key here, which maps to regions, countries, and continents. And then products are a little bit more complicated. We're going to get into this later when we talk about snowflake schemas. But what you may notice is that some of these tables actually contain more than one key. But for the time being, pretend like you never even saw that. Now shifting down to the data table, let's talk about foreign keys. So we know that multiple sales take place per day. So both of these date fields, order date and stock date, are both foreign keys because there are multiple instances of each value, and those dates can tie into the date field of our calendar lookup. Similar story with product key. We've got multiple sales per product. Same with customer key. Same with territory. So all three of these keys plus the two dates make up our foreign keys within the data table. So that's about enough for now. That's your crash course in data versus lookup tables and primary versus foreign keys. All right, one last conceptual lecture before we get our hands dirty and actually create some table relationships. And I really just want to drive home this very important idea of relationships versus merging tables. Now, I know some of you out there are thinking like this guy. Can't I just merge my queries or use familiar functions like lookup or related or index match to pull attributes into the fact table itself so that I have everything in one place? And the answer is yes, technically you can. You can create a table that looks like this, where you've got your original data, your metrics, your fact table fields on the left, just like the one we've been looking at with a date, a product ID, and a quantity field. And you could take those key columns and you could stitch in attributes from your calendar lookup table, attributes from your product table, and this could go on and on and on until you have hundreds of columns based on a handful of IDs or keys. And the thing is, this is a totally normal habit to be in. This was a habit that I had as a longtime Excel user, where it was this instinct to want to always blend and stitch things together and force my tables into one place. And there's a good reason for it. Before these tools came along, like Power Query and Power Pivot and DAX in Excel, there were very few user-friendly, intuitive tools that would allow you to do this type of data modeling work. So as a result, you were kind of forced to mash these different sources of data together into these Franken tables that contain all sorts of information, because that was the only way you could analyze it. Like if you wanted to use a traditional pivot table, for instance, you had to point that pivot table to a single data source or a single table. And that often required using hundreds of thousands of lookup or index match functions to tie this information together with brute force. So bottom line, sure, you can do this. Mechanically, it's possible, but it's just really, really inefficient. Like we talked about in that normalization lecture, merging data like this creates a ton of redundant information. As a result, it utilizes way more memory and a lot more processing power than simply creating relationships between multiple small, thin tables. So next time you feel that instinct to mash everything together, to merge it, to stitch it manually, just say no. All right, guys, it's an exciting moment in the AdventureWorks world because we are about to wire up our data model and create our table relationships. So in Power BI Desktop, there are two common ways to do this. Option number one, which I prefer, is to simply click and drag to connect your keys in the relationship view. So it's as simple as clicking on a foreign key, dragging the mouse, finding its primary key match, and releasing to create that relationship. Very, very simple, very straightforward, also a very visual way to create those relationships. The second option is to add or detect relationships using this Manage Relationships dialog box. So same idea here, just a little bit more manual. You would manually select the two tables that you'd like to relate, as well as the primary and foreign key columns. So without further ado, let's head into Power BI and add these relationships. All right, so here I am in the relationships view, and I'm going to show you the slow way to create a relationship first, and then we'll never do it that way again. I'm going to use the Manage Relationships button in the Home tab. And as you can see, I have a couple options here. You can choose Auto Detect and basically say, I don't know what my relationships are going to look like. Why don't you analyze the tables and tell me? Whenever I've played with it, it usually gets some of the relationships right, but misses others. So let's go ahead and disregard the Auto Detect option. And we're going to add a new relationship manually. And we're going to connect our sales table to our customer table. So AW sales to AW customer. And without even clicking on a column, Power BI automatically identified the foreign and primary key, that customer key column that matches these two tables together. And it gives us a little bit of information about the cardinality and the cross filter. We're going to talk about both of those in depth, as well as this make relationship active option later on this section. But for now, that's good enough. We'll press OK and close. And there you go. We've created our first table relationship between sales and customer lookup. And you'll see as you hover over this relationship line, it kind of highlights what the key column is. So you see that box around the customer key. So that's option number one, the manual way. The easier way is to click and drag. So to connect calendar to sales, I'm just going to grab my order date, and we'll talk about whether or not to use order versus stock in a little bit. But for now, let's focus on order date. And we're going to click and hold the mouse and just drag up and release it over the date field, which is our primary key in the calendar lookup. And there you go. We've created our second relationship. Same story with territories. Let's grab that territory foreign key, drag it up to the sales territory key in the lookup. And now before I connect up the product lookup, I want to return back to my report view for just a second and remind you that we had been looking at order quantities and trying to break them down by product names to no avail. Because remember, without the relationship, these two tables are essentially islands that can't talk to each other. But now, when we go back to relationships, grab that product key, drag it up to our product lookup, and oh, it's going to be tricky. There it is, product key. Created the relationship, and now, drum roll please, we go back to report, and look at that. We've got correct values for quantities broken down by product name. And again, this could be any field from the product table, all by simply dragging our mouse, making a couple clicks, and creating that relationship between the two tables. So let's hop back into our relationships view. And I'm just going to drag things around a little bit. You don't have to organize things exactly like I am. Really doesn't make any difference. Now, I'm going to hold off on these two tables. We're going to talk about these in the next lecture. And actually, I'm going to rearrange kind of in a hierarchical way. Product, subcategory, and category. But for now, we're good to go. So congratulations. We've officially just built an AdventureWorks data model. All right, time to talk about snowflakes. And I'm not talking about weather, I'm talking about schemas. Now consider this table structure here. This should look extremely familiar because this is the exact table structure that we're working with our AdventureWorks demo. We've got one data table, the sales data table at the bottom, and three product-related lookup tables: products, subcategories, and categories. Now, here's the thing. The sales data table can connect to products using that product key column, but we have no means of connecting the sales data directly to either subcategories or categories because we don't have any foreign key that can map to one of the fields in those tables. But fear not, we've got an alternative, and what we're going to do here is actually connect products to product subcategories because both of those tables share a product subcategory key, and then by similar logic, connect subcategories to categories because those two share a product category key. And in doing so, we've essentially connected sales data to each of those lookups in the chain. So when you create those actual table relationships, it looks something like this. So little pro tip here, models that have chains of lookup or dimension tables like this are often called snowflake schemas, whereas star schemas generally have a bunch of individual lookup tables surrounding one central data table. So let's hop into our relationship view and build out these product relationships. Okay, so we're back to our model in the relationships view. We've got these set up nicely to create that snowflake chain. And all we need to do here is connect the product subcategory key to the product subcategory key there, and the category key to the category key. And there you go. We've created our snowflake, our chain set of lookups that connects all the way down to that sales table. And that means we can filter or segment these order quantity values by fields in the product table or the subcategory table, or the category table. Now, interesting thing to call out here is that you'll notice that a table like this, product subcategory, or the product lookup table for that matter, contains both primary keys, in this case product key, and foreign keys, like the product subcategory key. Because in this case for products, you have unique values for product key and multiple values for subcategory. And the same thing holds in the subcategory table as well. It's got a subcategory key, which is primary, and a category key, which is foreign. So just an interesting thing to call out there. Tables don't necessarily have to have only a primary or a foreign key. They could potentially have both. So there you have it. We've created a little snowflake schema here, and we've officially wired up all of the tables that currently exist in our model. So go ahead and give the file a save, and then we'll move on to managing and editing these relationships. Let's take a minute and talk about managing and editing relationships, because nothing's set in stone in Power BI. In fact, it's very, very easy to edit, add, or delete table relationships. Now, within the Relationships view, you'll see this Manage Relationships option. That will show you all of the relationships that exist in your model and give you some tools to add, edit, or delete them. Now you can select an individual relationship and hit Edit to see some additional details. Which two tables are involved, which field they're connected by, in other words, which column contains the primary and foreign keys, and then also some editing tools that allow you to activate or deactivate the relationship, view the cardinality, or modify the cross-filter direction. So more to come on all of that stuff very, very soon. Now let's hop into Power BI and do a very quick basic demo. All right, so back in the Relationships view, we talked about this sales table and the fact that it has two date columns, the order date and the stock date. And at the moment, we can see that the relationship to the calendar table is using order date as the foreign key. But let's say we want to switch that to stock date instead. Well, from our Home tab, we can click Manage Relationships. We can navigate to that relationship, order date to calendar, and we can press Edit to see some additional options. And now it's really just as simple as selecting stock date instead of order date and updating the relationship that way. So I can press OK, close the box, and now when I hover over that relationship line, you can see that stock date field bordered in that black box. And now if we wanted to go back and maybe we changed our mind and we actually do want to use order date instead of going up to the menu and clicking Manage Relationships from there, I can also simply double click on that relationship line and jump straight to the Edit Relationship options. And go ahead and click order date, press OK, and I'm back where I started. So again, what you're probably starting to realize is that this data modeling, this relationship view is very, very user-friendly. In fact, you can add and delete relationships in really just a matter of seconds. For example, this customer key relationship to the sales table, I could right-click, delete that relationship, and then simply grab customer key and drag it back to the lookup table, and we're back in about 5 seconds. So again, Power BI makes it very, very easy and user-friendly to manage and edit your table relationships. There are two types of table relationships in Power BI Desktop, active and inactive. Consider a case like this. Our sales data contains two date fields, an order date and a stock date. And while you can connect both of them to the date field in the calendar lookup table, only one can be active at a time. That's why one of these relationships shows up with a solid line, that's the active one, and the other shows up with a dotted line, which is the inactive one. Now, if you edit both of these relationships, you'll see that one has the checkbox where it says make this relationship active, the other does not. Now you can toggle these back and forth, but the one catch is that you have to deactivate the active one first before you activate the other. In other words, there can be no point in time where both of those checkboxes are activated. So let me show you what this looks like in the Relationships view. Okay, so here we are back in our AdventureWorks model. As you can see, we've got these two date fields in our sales table, order date and stock date. Right now we're connected to the calendar table based on order date, which in this case is our primary date field. But what we can do is grab stock date as well without deleting our order date relationship and drag it up to date so that both are connected. Now you see that it added another relationship, one of which is dotted, which is the second one we added, stock date. The other is solid, order date. That's the active relationship. And remember, if I double click the inactive stock date relationship and try to activate it, it won't let me because it says there's already an active relationship between sales and the calendar lookup. So I've got to deactivate or delete that existing relationship before I can activate this one. So I need to uncheck, press OK. And basically the process looks like this. Start with order date, deselect to make that one inactive. Now I've got two inactive relationships here, and then I can double click and activate my relationship between the stock date and the calendar date. So there you go. I've just swapped the two. And because order date is my true primary date field, I'm going to go ahead and just reverse what I did. I want this stock date field to be available but not active. And my order date is the one that I really care about. So there we go. So again, I have both of these relationships in place when I do need them, but can only keep one active at a time. It's time to talk about relationship cardinality. Now, cardinality, by definition, refers to the uniqueness of values in a column. So for our purposes, all of the relationships that we're going to be creating with the data tables that we have in our model should follow a one-to-many cardinality. One instance of every primary key from our lookups, but potentially many instances of each foreign key from our data tables. So looking at the screenshot here, in this case, we have one instance of each product key in that product lookup table. You'll see that blue box around the number 1, since each row contains attributes of a single product, name, SKU, price, etc. On the data table side of that relationship, because there are many instances of each product key, which is the foreign key here, you'll see that the relationship terminates in an asterisk in that yellow box because there are multiple sales associated with each product ID. Now, the other types of cardinality that we're trying to avoid here are many-to-many or one-to-one. So I thought it would be helpful to put a little case study together for each of those two to show you why we'll be using one-to-many relationships instead. So our first cardinality case study is many-to-many. Now consider these two tables. You've got a product lookup table in green on the left, which has IDs, names, and SKUs. And you've got a data table in blue on the right, which has dates, product IDs, and transactions. So if you were to try to create a relationship between these two tables, you'd get an error message that looks something like this. Power BI is going to tell you you can't create a relationship between those two columns because one of the columns must have unique values. And as you can see above, we've got two instances of product ID number 4 in the lookup table and 3 instances in the data table. So now let's take a minute and step back and really think about this for a second. Even if we had some magical way to force this relationship to stick, it really just doesn't make sense logically. So we know that product number 4 was sold 12 times on January 1st, 9 times on the 2nd, 11 times on the 3rd. But since ID number 4 is associated with multiple product names, how do we know how many of those sales or transactions were for Washington cream soda versus Washington diet cream soda, which for the record sounds like the worst beverage on the planet? That's not relevant here, but you get my point. There's no way to make sense of this data with the tables in this kind of form. Now let's move on to our second cardinality case study, one-to-one. Now compared to many-to-many, this one's not nearly as bad. In fact, you can create one-to-one relationships. They're just a little bit inefficient. So consider these two tables. You've got a product lookup on the left, just like we showed before, but without those duplicate ID number 4 rows. And then almost like a smaller product lookup in orange on the right with product IDs and product prices. So if we were to connect these two based on product ID, we're creating a one-to-one relationship since each ID only appears once in each table. So again, unlike many-to-many, there's nothing illegal about this relationship. It's just kind of an inefficient way to do things. So to eliminate the inefficiency, what you could do here is simply merge those two tables together into a single valid lookup. Now, I know what you're thinking. I've been telling you this whole time never to do merging, it's inefficient, use relationships instead. But trust me, in this scenario, it's legit because we're still respecting the laws of normalization. All of our rows here are unique, and this merged blended table still captures attributes related to the primary key. So it still serves one single purpose. So there's your cardinality crash course. Now let's jump back to Power BI and make sure that our relationships follow a one-to-many cardinality. So back in our relationships view, what we're looking for here is that the lookup table side of each relationship shows a 1 and the data table side shows an asterisk. One instance of the primary key in the lookup table, many instances of the foreign key in the data table. So customer lookup looks good, calendar lookup on order date looks good, calendar lookup on stock date looks good, territories one-to-many, product one-to-many, and then we can follow our way right up the snowflake, one-to-many, one-to-many. So it all checks out. We've got a good set of one-to-many cardinality relationships, so we're in good shape. All right, it's time to shake things up a little bit. To this point, we've been dealing with a pretty simple, straightforward model, just our one data table, that sales data table, and a bunch of individual lookups that we've created connections or relationships to. Now, here's the thing. I just got off the phone with our client at AdventureWorks, and it turns out that they have another data table with information about product returns that they'd like us to integrate into the model as well. So in other words, they don't just need us to analyze product sales, but they want to get a sense of which products are being returned most often as well. So what we're dealing with here is something like this. In this particular case, we've got a simplified model with 3 lookup tables, customer lookup, calendar and product lookup, and 2 data tables, sales data and returns data, each with its own set of dates and other foreign keys. But take a minute and look at the relationships here. What you'll notice is that the sales data is connected with one-to-many relationships to all 3 of the lookups, customer lookup, calendar, and product lookup. But the thing is, the returns data is only connected to the calendar and the product lookup. We don't have any way to connect returns data to customer lookup since we don't have a foreign customer key. And this isn't entirely uncommon, especially for larger or more complex real-world models where you're pulling in data from a number of different sources. It's actually quite uncommon to have the exact same set of foreign keys in every source data table that you're working with. So this is the type of scenario that you may very well run into in a real-world application. So what this means is that we can analyze sales and returns data, sales quantities and returns quantities, within the same view or visual in Power BI, but only if we filter or segment our data using fields from shared lookup tables. So looking at the returns data in this particular case, we know which product was returned because we have a product key, and we know which date the product was returned because we have a return date, but we know nothing about the customer who made the return. So there's no way we could slice or dice or filter that returns data by any field in the customer lookup, like names, marital status, gender, income, any of those fields. So what you may be noticing here is that we've successfully integrated that returns data into the model, but we did not attempt to make any kind of relationship between the returns data and the sales data. And the reason for that is that no matter which fields we tried to use to form a relationship between those 2 data tables, we're always going to run into a many-to-many relationship error. And that's because both data tables, sales and returns, have multiple dates in the date field. They have multiple products in the product key field, multiple territories in the territory field, and so on and so forth. So even if we wanted to connect those 2 together, there'd be no way because we have no field that would give us a valid one-to-many relationship. So that's a very, very important point. Generally speaking, you will never create direct relationships between data tables. Instead, you connect them indirectly through shared lookup tables. So what we're going to do now is jump back into Power BI. We actually have that returns CSV file that we're going to load up, and then we're going to wire it into our model, creating relationships just like the ones you see here. All right, so once you're back in the relationships view of your AdventureWorks report, go ahead to the Home tab and click Get Data. We're going to get our last file of the project. It's another CSV. And this time we want AdventureWorks _ returns. So go ahead and double click. Take a look at the preview. Pretty simple data set here. Got a return date, a territory key, product key, and that numerical quantity field as well. So let's edit this file to fire up the query editor. And first things first, let's head to our table name and call this one AW returns. Check our headers. They're promoted. We've got dates for return date, whole numbers for territory key, product key, and quantity. Very straightforward. All looks good. Let's go ahead and just close and apply just like it is. And we'll see that object pop in right here in our relationship view. There we go. So here's our second data table. I'm going to kind of click and drag and make some room for it here. And I want to make it clear that these two tables here are the two data tables that we care about. Now remember, I can't just grab a field, a foreign key from my returns table and try to force a connection right to my sales table, because I'll get that many-to-many relationship error. You can't create a relationship because one of them must have uniques. So press OK, and the same holds even if I try to use my keys. Territory key to territory key, can't do that either. So again, the way that we integrate a second data table, or a third or a fourth or a fifth for that matter, is by wiring it in and creating the same relationships just like we would with any other table. So territory key can connect to territory key, return date can connect to calendar date, and then last but not least, product key can connect to product key, and by association, product subcategory and category as well. So again, no customer key means that we can't form a relationship with that customer lookup table. Now, to really hammer that point home and understand how this impacts our analysis, let's jump all the way back up to the report view. And as you can see, we've still got our matrix here showing product name and order quantity. So what I'm going to do is select that matrix. You can see my returns table has populated here. I'm going to grab return quantity and pull it in right under order quantity in my values. And I can expand to view and take a look. This looks great. I'm now seeing order quantities and return quantities side by side in the same visual, broken down by product name. So that's really helpful, and I can get a lot of insight from this. But what if we want to see this same view, these same values, broken down by gender instead? I'm curious if men or women tend to return items more frequently. So instead of product name, let's pull that right out of our matrix. And let's go ahead and drill into our customer lookup. And right here we can find gender, pull that into rows, and take a look at this. We see the order quantity, which seems to be correct, but for return quantity, get that same repeating number issue that we've seen in the past. And almost every time you see that repeating number issue, it's because of a relationship problem. And in this case, the relationship problem is that we're trying to apply a filter from the customer table and show values from returns, which is an unrelated, disconnected table. And that goes back to the point that I made earlier. You can only view fields from both of these data tables in the same visual when you're filtering or segmenting using a field from a common or shared lookup. Since the customer table is not shared by both of these, this is an invalid view, and that's why we see these duplicate, erroneous values. So let's jump back to our relationships view. And this is our finalized data model. So we've got all of our tables in here. We've got all of our relationships in place. This is going to set us up for some really interesting analyses down the line. But before we move on to calculated fields with DAX and then visualizations, we need to hit one more really important concept when it comes to data modeling, which is the filter flow. So stay tuned, that's coming up next. All right, time to cover one of the most important lectures, certainly in the data modeling section, but perhaps in the entire course. Let's talk about filter flow. Now to demonstrate, I'm going to use a very simple example. Here we've just got a 3-table model, 2 data tables, sales and returns, both with valid connections or relationships to a single lookup, territory lookup. Now when you look closely at the 2 relationships, you'll note the filter directions, which are shown as arrows, point from the one side of the relationship, or the lookup side, to the many side, the data side. And when you filter any table, that filter context is passed along through that relationship line to all related downstream tables, following the direction of the arrow. And by contrast, filters or filter context cannot flow upstream. In other words, it cannot flow against the direction of the arrow. So you can almost think of these relationships as filter wires, because that's all that relationships do is they pass filter context back and forth between tables. Quick pro tip, one thing you may have already noticed that I've been doing is that I like to arrange my lookup tables above my data tables in every data model that I build. And that just helps serve as a visual reminder that filters flow downstream from those lookups down to your data tables. So let's look at a visual representation of why filter flow is so important. We're going to look at that same simple 3-table model, and let's say we want to analyze sales and returns broken down by territory key. Now, the only valid way to do that is to use the territory key field from our lookup table. And when we grab that field from the lookup, pull it into our matrix rows, we see the proper, accurate values for order quantity and return quantity, both broken down by territory. Now, the reason we get the correct answer here is because that filter context that we created by using the territory key in the lookup table is able to pass or flow downstream to both the sales table and the returns table. But keep in mind, we also have a territory key in the returns data, as well as a territory key in the sales data. So technically, there are 3 different ways we could try to replicate this view. So let's take a look at what happens when we try to do that. Filtering using territory key from our sales data table will yield the correct order quantities, since those come from the sales data table, but incorrect returns values. And the reason that's the case is that the filter context that we created by using territory key in the sales data table is stuck in this table. It cannot flow up through this relationship because it can't flow against the direction of the arrow to filter either the lookup or the returns data. So as a result, the return quantity knows nothing about the filter context that was set from using the territory key in the sales data table, and therefore just returns the same grand total value over and over and over again. Now, very similar case, if we try to use the territory key from the returns table, we see the correct value for the return quantity now, but incorrect values for order quantity, because the filter context that we created by using the territory key in the returns data is stuck in the returns data table. It can't filter the lookup or the sales data table. So just like our last example, order quantity now knows nothing about the filter context passed from the returns data table, and therefore returns the grand total over and over and over again. In addition to that, you'll notice that this table is smaller. It contains fewer rows, and that's because only territories that registered returns are even going to be visible in this table, since the filter is taking place within that returns data table. So we don't even see data from territories 2 and 3, even though they registered orders. So this is a little bit tricky to grasp at first, but it's an incredibly important concept that's going to come up time and time again as we start working with more complicated concepts like DAX formulas and interactions between visuals in the report view. So to really drive this point home, let's hop back into Power BI and build our own matrix visual to see this filter flow concept for ourselves. All right, back in my report view, in my AdventureWorks file, I've got the same matrix that we just showed in our last video. And to follow the demo that we just talked about, I'm going to select the matrix And instead of gender here, let's go ahead and find our territories table. There it is. And we want the sales territory key. We're going to drag that into rows. So just like we were demonstrating, we've got 10 sales territories, 1 through 10, and we're seeing proper order quantities and proper return quantities. And you can see from that last example that territories 2 and 3 did not register any returns in our sample, so those cells are blank. So this is an accurate, valid view for orders and returns by sales territory. But just like we demonstrated, if we pull sales territory out of the rows and we drill into the actual sales data itself and grab the territory key from there, when we drop that one into rows, now you'll see that return quantity duplicated every single row. But you'll still see all 10 territories because all 10 territories generated orders. And I think you see where this is going. We can pull territory key out, drill into our returns table, grab the returns table version of the territory key, and there you see that order quantities are now duplicated, return quantities are correct, and those 2 territories that did not register returns don't even show up here in the matrix because they were filtered out from the start. So hopefully this demo starts to give you a sense of why filter flow is so important to understand. Making sure that we have a crystal clear understanding of our model's filter flow will be critical for making sure that the views we're creating, the filters we're using, and the numbers that we're showing are 100% accurate. Now, when it comes to filters, there's one important difference between Power BI and Power Pivot for Excel, and that's that Power BI actually enables you to create two-way or bidirectional filters. So let's take a look at that familiar 3-table model. Just like we've seen before, with one exception, that relationship between territory lookup and sales data now contains a bidirectional filter. So by updating the filter direction in that relationship between sales and territory from single to both, we've essentially allowed filter context to flow in either direction. And what that means is that filter context could flow from the territory lookup down to the sales data, just like normal, but it could also flow from the sales data up to the territory lookup, and then from there down to returns. So what we'll see now is that we can control and filter returns data using filter context from within the sales data table, which is something that we could not do using the one-directional filters in the last lecture. So let me show you what that looks like. Here we go, same 3-table model. The only difference is that one bidirectional filter between territory and sales. And because we've enabled cross-filtering between those 2 tables, we can now see correct values using the territory key field from either one of those tables. So again, just like before, using the territory key from the lookup will yield proper, accurate values for both order quantity and returns quantity, since it's upstream and connected. What's new now is that pulling in the territory key from the sales data will not only return proper order quantities as you'd expect, but that filter context is now able to travel up to the territory lookup, which then filters territories based on which ones generated sales, and then that filter context in turn passes down to the returns data table, which filters accordingly as well. So we've essentially created a way to transmit filter context from within the sales data table all the way to the returns data through the territory lookup. Now, as you'd expect, if we pull in territory key from returns, same story as before, that filter context is trapped in the returns data table because we've got that one-way relationship between territory and returns. So let's keep this idea going a little bit and consider a similar model with one difference, which is the bidirectional or cross filter now exists on the relationship between territory and returns instead of sales. What we see this time is that, as always, the territory lookup version of territory key returns the proper values. The territory key pulled from the sales data table returns incorrect return quantities because now that filter context is trapped within the sales data table. But here's where it gets interesting. When we pull in the territory key from the returns data table, the returns are accurate, which we know will be the case, but check out territory key and order quantity. At first glance, things look good, but remember that territories 2 and 3 don't even exist in the returns table. So since no information about territory 2 or 3 ever gets passed up to the territory lookup, then they'll subsequently get filtered out of the sales data table as well. So the filter context that we created by using this territory key field from the returns table is properly flowing up to the territory lookup and then down to the sales table, but in doing so, it's yielding misleading data. And this is dangerous because this type of issue can be very, very difficult to detect, even if you know your data model inside and out. So had we not gone through this exercise, we may never have realized that territory 2 actually drove an order quantity of 40 and territory 3 drove an order quantity of 30. But because of the way our filter context flows, those values get completely stripped out of this view. So that brings me to my next point, which is a word of warning about two-way filters. The fact is you've got to use two-way filters carefully and only when necessary. Now there are cases where two-way filters are helpful or sometimes even necessary. Like for instance, if you want to intentionally filter a lookup based on a data table, kind of like we just showed. But the thing is, two-way filters really aren't recommended for models with multiple data tables, exactly like the one that we're working with. And in fact, if you try to use multiple two-way filters in a more complex model like this, you run the risk of creating something called an ambiguous relationship, because you're essentially introducing multiple filter paths between tables that could potentially contradict each other. So consider this data model shown here on the left. We've got the same three tables that we've been looking at, plus now a product lookup table as well. And you'll notice that there are two bidirectional filters here, from territory lookup down to sales and down to returns. What's important to call out here is that only one of the relationships from the product lookup table to the data tables can be active at one time. If you tried to activate both, you'd see an error message like this. It basically says you can't create a direct active relationship here because it introduces ambiguity. So you've got to either deactivate or delete a relationship or change one of your bidirectional filters to one way. So very, very confusing and not really intuitive at first glance. So I'm going to take a stab at explaining this to you in plain English the best way that I know how, but this is a little bit nuanced, so it might be one of those cases where you're going to need to step back, pause the video, maybe rewatch it a few times before it starts to really click. So here's the deal. Let's imagine that we want to filter our data for a specific product. And to start, all we care about is the relationship between product lookup and returns, which is currently active in the model that we're seeing here. So for the sake of example, we want to filter down our data to just the product named racing helmet. Okay? So that filter context, product name equals racing helmet, passes down, it flows downstream right to the returns table. And as a result, that returns data table filters down to only rows where that racing helmet was returned. Now, if that helmet was only returned in territories 7 and 8, because territory keys 7 and 8 were the only ones remaining in that filtered down returns table, that's the context that gets passed up to the territory lookup through that bidirectional filter and tells that territory lookup table, hey, there are only two territories that exist in the universe, 7 and 8. Now, shifting gears to the relationship between the product lookup and the sales table, let's go through that similar thought process here. Imagine we could also activate that relationship. That way we can say, all right, product name is racing helmet. Let's allow that filter context to flow down to the sales data table, just like it flowed down to returns. Except now this time the sales data table is going to collapse and filter down to only rows showing records where that racing helmet was sold. And if that racing helmet was sold in stores 7 and 8, as well as 1, 2, and 3, then that filter context also would pass up to the territory lookup through that bidirectional filter and tell the territory lookup, hey, there are 5 territories that exist in the universe, 1, 2, 3, 7, and 8. So what we've done in this hypothetical situation is pass two conflicting sets of filter context to that same territory lookup table. The returns data table is telling the territory lookup that the only territories that exist are 7 and 8, and the sales data table is passing along different information and saying that territories 1, 2, 3, 7, and 8 are the 5 territories that exist. So that's what we mean by ambiguity. Both can't be true at the same time, and all we end up doing is confusing Power BI and confusing that territory lookup table in a way that prevents our model from producing or yielding meaningful values. So as a result, Power BI forces you to keep one of those relationships inactive so that you can't possibly pass conflicting filter contexts to the same table. So at the end of the day, that's really just a long-winded way of saying we don't want to use two-way filters in our particular model. And as a pro tip, rule of thumb, I'd recommend that you try to design your models with one-way filters and one-to-many cardinality, especially as you're first learning, unless more complex relationships are necessary. So with that, let's take a quick peek at what this actually looks like in the Power BI environment. All right, so in the AdventureWorks report, I'm going to start in the report view first. And as a reminder, I've got my matrix here. And one thing that you can do is actually hover over the field that we've pulled into a row list to confirm exactly which version of territory key we're looking at. In this case, we can see that it's coming from the AW returns table. So remember that we've got the key from our returns table, and we're getting incorrect order quantities here. When we jump to our relationships view, and we find that relationship from returns to territories, we can double click to edit, drill into this cross filter direction, change it to both, and press OK. See that little arrow switch from one direction to both. And now when we return to the report, this is exactly what we had talked about. So now order quantities look to be correct, and to the untrained eye, the initial reaction is to flash a thumbs up and say, okay, we're good to go. You know, we've got order quantities broken down by territories. We've got returns by territories. But again, remember the problem here is that we are missing data. There are actual valid order quantity values for territories 2 and 3 that aren't showing up because by using territory key from the returns table, we've filtered them out from step 1. So now let's go back to relationships. I'm going to double click that same relationship, change it back to single, press OK. And I'm going to find the relationship from sales to territories. There it is. I'm going to make this one bidirectional, press OK. Head back to report, pull out the territory key from returns, and pull in the territory key from sales. And here's what we see. In this case, we see the correct values from both, but only because each of the 10 territories registered a sale or showed up in that sales data table. So important nuance there. These numbers could very well be incorrect as well had there been one of the 10 territories that didn't show up in the sales data. We'd have the same issue that we just had with territories 2 and 3 in the return table. So last little demo here, back to returns. If I go back to the relationship between territories and the returns table and double click, watch what happens when I try to click both here. I get this error that says you're trying to create an ambiguous relationship. You can only have one filtering path between tables in a data model. So you can't even press OK. You have to deactivate one of those existing relationships, or unless at least one of those filters was changed back to single direction. So for the sake of our model, I only want one-way filters because I don't want to introduce the potential headaches that we just talked about. I'm going to go back to my sales territories relationship, change that back to single as well. There we go. And now just for good measure, let's go back to report, pull that territory key from sales out, and let's grab the proper one from our lookup table and drop it in rows. So I know that was probably a little bit confusing at first. Again, I'd recommend rewatching this a few times until it starts to make more sense. But the one big takeaway from this entire conversation is that for our purposes, we will not be using two-way filters, and therefore we will never pull in foreign key fields from our data tables. So it's going to keep things simple. It's going to keep things accurate. From here on out, every time we filter our data, we're going to do so using fields from our lookup tables. Okay, so after talking about filter flow in depth and learning about the risks of using bidirectional filters and the pitfalls of pulling in a foreign key instead of a primary, you may be thinking to yourself, man, it is really easy to make major mistakes in Power BI. And to some extent, that's true. Without having a good fundamental knowledge of how data models and filters actually work, it certainly can be easy to make this type of mistake. But the good news is that Power BI gives us tools to help prevent this type of thing from happening. For example, hiding fields from report view. Now, in either your data view or your relationships view, you'll have this option called hide in report view. And you can simply right click on either a column, a field, a measure, or an entire table and choose this hide in report view option. And what that does is essentially make that field or table inaccessible from the report tab. It makes it invisible. So you can still access the data and see the information within the data or the relationships views, but end users in the report view will not be able to access those fields. So this is a really common way to prevent users from accidentally filtering using invalid fields, like a foreign key from a data table instead of a primary key from a lookup. So pro tip here, my recommendation in general is to hide the foreign key columns in your data tables, which will force users to filter using the primary keys from the lookups, since that's the only option they have left. So let's go ahead back to our AdventureWorks demo and work on foolproofing this model. All right, so we're back in our AdventureWorks report. We're in the relationships view looking at our model, and I want to show you how to hide some of these fields. First of all, you can select an entire table, right-click the header, and hide a whole table from report view, which will essentially gray it out. But we don't want to do that in this case. We need information from all of our tables, including the values or quantities from returns and sales, at least for now. But what we can do is start hiding some of these foreign keys, because 99% of the time, we don't want users filtering on dates or products or customers or territories within the data table itself. You can access that same exact information using fields from the lookup tables instead. So all we need to do is hover over the field, right click, and click hide in report view. You might see it flash at you like that. That's okay. We're going to do the same thing for stock date. There we go. It grays out. That means it's now hidden. We can keep order number in there, but let's hide product key and customer key and territory key. There we go. So all 5 of those foreign keys, the one that connects to customer, the 2 dates that connect to calendar, and the connections to territory and product are now hidden. And we'll do the same thing for returns, return date, territory key, and product key. So we haven't lost anything. You can easily right click and re-enable any of these fields. And also note that we could have done the same thing in the data tab as well. You'll see we're in our sales data now. Those columns that we did hide are now grayed out. You could also select or right click the column header and choose the hide and report view option there as well. Just 2 ways to do the exact same thing. So now here's the real impact. If we go to the report view, here in my fields list, you'll note that my returns table only has that one lonely field, and my sales table has been chopped down to just these 3. So remember, hiding from report view makes them invisible or inaccessible, but only within this one view. So there you have it. That's a great way to foolproof your data model and your Power BI reports by hiding fields from report view. All right, so if you just worked through that section and noticed that your screen looked quite a bit different from mine, that's okay. Let's talk about what some of those differences look like. Since recording the course, Power BI has gone through a number of updates that have changed the look and feel and functionality of the platform. So the first thing you'll probably notice is a view like I'm showing here. We've got this default light mode, which is very bright and airy and light, compared to the default dark mode when Power BI was first released, which had a lot of blacks and dark grays. Now that was just a purely stylistic change, so nothing really to talk about there. But where we do see some additional differences is inside of that relationship view, which is now called the model view. So the first thing you've noticed, I'm sure, is the addition of these two new panes here called properties and fields. Now, these aren't adding a lot of new tools or features to the platform. They're just making existing features a bit more accessible and user-friendly. So now I can select objects from my model, either entire tables like so, or individual fields, either from the model canvas or from the field list here on the right. And as I do so, I have access to different properties that I can customize right here, like the name, synonyms, description, whether or not it's hidden from report view, and I've got advanced features or properties that I'll walk through as well. So table name speaks for itself. Synonyms, these are automatically generated. They don't really mean much in the desktop environment, but if we were to publish this file to Power BI Service online, they've got some great features there like natural language questions, which allow users to actually type in questions to retrieve information or insights from their model. So instead of forcing users to type the name exactly as shown, capital AW_calendar, you can use different variations with lower cases, spaces instead of underscores, and Power BI will recognize that you're referencing the same thing. And then down here in the advanced options, you've got storage mode, either import, direct query, or dual. Now, this is a little bit outside the scope of this course, but just in a nutshell, to give you a sense of what the difference is, import means that you're grabbing data from your source and actually loading that data into the Power BI environment. Direct query, on the other hand, is when you've got source data that's typically stored in a database, data warehouse, or data lake, like Access, SQL, Azure, and you're asking Power BI to send queries to that source data to retrieve the data that you need, as opposed to actually storing the data here inside of Power BI. So in this case, we're using import because we're actually grabbing data from those CSV files and loading them here into the system. Again, a little bit outside the scope of the course, but just wanted to cover that quickly. And same goes with individual fields here. If you select one individual field, you've got properties at the field level as well. Name, synonyms, description. Display folder is something that's a little bit new. It's purely for the sake of organization, but if you've got fields that are related in some way and you want to organize or group them together, but they don't follow a hierarchy necessarily, you can create a folder just to organize things a little bit more clearly. So to give you a quick example, let's drill into product lookup. You can follow along if you'd like. I'm going to delete this in a minute so you don't have to. But let's say we want to take the model name, the product color, the product name, and style, for instance, and put those into one folder. This is something that's new with this view that I couldn't do before, which is I'm going to select a field, hold Control, select the others, like description, name, style, just kind of arbitrary, but let's grab those 5. And I've multi-selected those, and I can say let's throw those into a display folder called product detail. Press enter. Boom, we've got that new folder right there inside of our product lookup table containing those 5 fields. And that change carries through the entire platform. So jumping into the data view, there's that folder I just created. Let's go back to model, and then getting rid of it is just as simple. Right click, delete from model. It won't get rid of the component fields, it just gets rid of the folder containing them. So nice little organizational feature right there. Again, you can hide multiple fields from view in one sweeping pass, one go, instead of right-clicking each field individually like we used to have to do. And then you've got formatting options here as well. So data type, data format. Let's actually select a numerical field as well, like order quantity. You can see order quantity is a whole number. You can change the percentage or thousand separator formatting. And then you've got some advanced features as well, like sort by column, the data category, which is great for mapping. So you can set things like region or postal code to help Power BI map those geospatial fields more accurately. And you can change the summarization mode as well. So default to a sum, a count, an average, no summarization at all. And you can do this for any field here in your model. So those are the properties. They're pretty straightforward. I'd recommend kind of working through these, getting comfortable with your options here. And again, these are the same tools that we've talked about and that we'll continue to talk about here in the data view. If you go to the modeling tab, you've got field properties accessible right here in your toolbar as well. So again, these aren't brand new features. They're just making them a little bit more accessible and user-friendly here inside of the model view. Now, last thing that I want to quickly cover here is the fact that now we have tabs available at the bottom of the screen, which we didn't have before. And by default, you'll see this one tab called All Tables, which means you're viewing your entire model. Now, one common question is, how do I make this bigger or smaller? Sometimes you get to this view and you see something like this, which is totally ridiculous. You can't even read what your table names or fields are. They've put the little zoom bar, it's kind of hidden, but it's all the way down here on the right, and you can click the plus sign to make that view a bit bigger. But getting back to the concept of tabs, what these tabs allow you to do is create new views of your model that basically contain subsets of the tables. So if you've got a really complicated model with hundreds of tables and relationships, and you want to kind of zoom in on a specific component of your model to help users understand how it's built, you can create these different layouts. And check this out. If we want to create a layout containing our sales information, we can grab that sales table, just drag it right in the canvas there, and then if we want to show which related tables are connected to sales, we don't have to drag those in, we don't have to create new relationships again. We can just right click anywhere and say, let's add the related tables. Boom, with one click, there you go. It's pulled in calendar, product, territories, and customer tables with those relationships still intact. So again, we're looking at a subset of our all tables view, which is the entire model. We can go ahead and double click, call that something like sales, and then check it out. We'll do the same thing for returns. There we go. AW returns, right click, add related tables, pulls in product, calendar, and territories. Double click, call it returns, and there you go. So now we've created these very specific views to help users understand different slices or components of our full model. And then getting rid of those, it's as simple as just clicking that little X and confirming. So there you have it, kind of a quick 10,000 foot view or tour of this new model tab. Hopefully that helps. All right, we've officially reached the last topic of our data modeling section. Let's talk about best practices. First and foremost, focus on building a normalized model from the start. Remember, that means that each table in your model serves a single distinct purpose. You should be using relationships over merged tables whenever possible. At the end of the day, creating relationships between multiple long and narrow tables is better and more efficient than merging them together into a bunch of short and wide tables. Number two, organize lookup tables above your data tables in the diagram view. This is not required. It has no impact to performance or calculations or anything like that. It really just serves as a visual reminder and a little cue that those filters do flow downstream from your lookups down to your data tables. Number three, try to avoid complex cross-filtering unless absolutely necessary. So we talked about some of those warnings with two-way filters. So avoid using them unless you absolutely have to, and especially when a one-way filter will get the job done. Last but not least, hide fields from report view to prevent invalid filter context. My recommendation is to hide the foreign keys from data tables unless you need them, so that users aren't able to access invalid fields for filtering. So there you have it, my personal best practices for data modeling in Power BI. All right, congrats. You've made it to the end of the data modeling section of the course. Last item here is to cover the homework solution walkthrough, and then we'll move on to calculated fields with data analysis expressions or DAX. So let's jump right into question one. We need to navigate to our relationships view. Here we are, and perform two different actions. First, we're going to right click to delete each relationship between AW sales, AW customer lookup, and AW calendar lookup including both of these date fields. So let's go ahead one by one, right click, delete, confirm, right click, delete, confirm, and you guessed it, right click, delete, confirm. So we had a nice, beautiful, fully functional data model, and now we are going to tear it to pieces. But don't worry, we're going to rebuild it. A big part of the reason we're doing this is to showcase just how easy it is to do that. So now I could continue on and right click each of the remaining relationships here, or if I'm doing a bulk action kind of like that, I like to use manage relationships in that case, where I can hold shift and select the last item to get all of the relationships selected. I can delete in one pass. There we go. When we confirm and close out, they all disappear at once. So a little bit more efficient approach. So that's question 1. Easy enough, pretty straightforward. Question 2, which you may have anticipated, is that we're going to now recreate those table relationships for ourselves from scratch. And we can use any method we choose here, whether it's the manage relationships option or the click and drag approach. I prefer click and drag, so I'm going to go ahead and take that approach. And I'm just going to start with sales, wire up the full sales model, and then move on to returns. So let's go ahead and get started. I'm going to go in order of the fields in my sales column. So order date to date, that defaults to my primary active relationship. Stock date to date, which comes in as an inactive relationship because we can't have two relationships, both active, from one table to the same primary key. So because I dragged my order date first, that's the one that gets priority. That's the one that gets activated. Moving along to product key to the product lookup, customer key to the customer lookup, and territory key to the sales territory key. Same deal with returns. We're going to pull return date, connect it to calendar date, territory key to sales territory, product key to product key. And now let's go ahead and build out our little snowflake here, subcategory to the subcategory key, category to category key. So there you have it. It probably felt a little bit scary when we deleted all those relationships. It felt like a whole bunch of work kind of going down the drain. But look at that. In about a minute, we've completely rebuilt our entire model. So now that we've recreated the relationship, question 2 asks us to confirm a few things. So number 1, cardinality is one to many for all relationships. So I'm going to look at my lookups first, and I'm looking for that 1 icon. So that indicates that I'm connected to a primary key on this side of the relationship. Customers look good. Calendars look good. All 3 connections from there. Territories 1, 1. Product 1, 1. And then again, same thing with my snowflake. Each of these are serving as primary keys, and my product and subcategory tables are also serving as foreign keys as well. So I've got 1s on the lookup side of every single one of my tables, and I've got asterisks which indicate the many side of the relationship on both data tables. So that one checks out. Number 2, filters are all one way, no two-way filters here. So I'm looking at the arrows now, checking that A, the relationship points to the data table downstream, and B, it's only a single arrow, not a bi-directional arrow here. Looks good, looks good, looks good. Okay, number 2 checks out. 3, filter direction correctly flows downstream to the data tables. We just did that by checking the direction of the arrow. Data tables are not connected directly to one another. As you can see, both data tables are connected to each valid lookup, which makes sense. We did not try to force any sort of crazy many-to-many relationship between sales and returns. So that one checks out as well. That hits number 5, connected to all valid lookups. We can confirm that each of the foreign keys in our data tables is currently connected. Order date, stock date, product, customer, territory from sales, return, territory, product from returns. So all we have left are some of these numerical values. We've got an order number in the sales table that's not connected to anything, which is okay. We've got our order line item and our order quantity, as well as return quantity for returns. And then last little item in question number 2 is that our product related tables follow a snowflake schema, which as we can see, they do. We've got that lookup chain extending out from the data tables. So that wraps number 2. Let's go ahead and move on to number 3, which is returning to the report view. So let's go ahead and head back to our canvas, and we're going to edit our matrix visual to show return quantity by category name on rows from the AW product category lookup table. So in this case, we don't need order quantity yet, and we're not showing this by sales territory key. We've got return quantity here in our values, and we need category name from the product category table, which we can drag this pane a little bit out so that we can read it better. So category name on our rows. So there you have it. Which category saw the highest volume of returns and how many? Looks like accessories drove the highest volume at 1,130 total returns. Next up, we're going to replace this category name with year from our calendar table. So we'll delete that. Drill into calendar. One note here, you can use the search bar as well, which gets really helpful if you have tons and tons of fields. We're going to be building out a number of new measures, so this field list is going to keep growing. So you can just simply search for a text string like year. You can see, okay, in my calendar lookup, I've got this year field, which is what I want in this case. I'm going to drag year into rows, and then you can just delete that search bar, take you back to the full list. So this part of the question asks, okay, how many returns do you see in 2015 versus 2016? In this case, I see a total of 86 returns in 2015, 770 in 2016. Last but not least, let's pull year out and drill into our customer lookup table. We need the full name column from here. We're going to drag that into our rows. So what do we see and why do we see it? Well, obviously what we see is a series of repeating identical return quantity values, 1,828, which also happens to be the grand total, not a coincidence. And the reason why we're seeing that is because we're trying to filter on a field from the customer lookup table. And because we don't have a relationship between the customer lookup and the return table, there's no way for that filter context to pass down to the data table to filter those values properly. And then last item for question 3, we're going to update this matrix to show both order quantity and returns by product key from the product lookup table. So let's go ahead down to our sales table, drill in, we need order quantity. I'm going to pull it in front of return quantity, doesn't really matter. And now instead of full name, we're going to drill into our AW product lookup table and grab the product key from there and drop that on rows. So here we go, orders and returns by product key from the lookup table. So what was the total order quantity for product number 338? Here it is. We've got total order quantity of 50. So make sure you're seeing a total of 50 for product 338. Now moving on to question 4, what we need to do now is unhide the product key field from our returns table. And we can do that using either approach, from the data view or the relationships view. We kind of go in order to data. We're in our returns table here. I could simply right click and click the hide and report view to uncheck that option. Now you can see it's no longer grayed out here. Again, we could have also done that from the relationships view by right clicking the field itself and choosing this second option. Now if we return to report and get rid of product key from the lookup, which yields correct values, go into returns, grab that version of the product key, which is now visible, and pull that into rows. Now we see that issue with our order quantity values. So that same grand total, 84,174 in every single row. And remember, the reason why that's the case, and sometimes it's helpful to visualize this, is that we created filter context by using product key out of this returns table. Since that filter context can't pass upstream against the direction of the arrow, it can't transmit up to the product lookup table, and therefore has no possible way to get to the AW sales table, since that's the only possible path between returns and sales. So as a result, the data here in the sales table, the values of order quantity, have no idea that you just filtered anything in AW returns. Therefore, it knows nothing but to return that same grand total unfiltered value over and over and over again. So here's where things get a little bit interesting. Let's actually edit this relationship between AW returns and product lookup. And what it asks us to do here in the second part of question 4 is to change the cross filter direction from single to both. And when we press OK, we'll see the little arrow icon convert from a single arrow to a double arrow. Now we have a two-way relationship between returns and product. And now returning to our matrix, we see what appear to be correct versions of this order quantity field, or these values. So the reason why we no longer see duplicates here is because we've essentially enabled the filter context from filtering down here in the returns table to transmit up to the lookup, which is then able to pass down to sales. So now sales has some insight into what you just filtered in the returns table, because we've kind of allowed that filter context to escape. It's no longer trapped in that returns table. We've given it an exit through this relationship to product lookup. But before we celebrate, let's talk about product 338 again, which if you remember in question 3, we saw that it generated 50 sales or 50 orders. So let's go down and look for 338. And as you can see, we jumped from 336 to 340. It's completely missing from the table. So what is going on here, right? And this gets back to our whole word of caution, word of warning about using two-way filters. So remember, when we created that filter context by filtering product keys in the returns table, we passed along that context to the AW product lookup table, but that context, that filter information, only included territories that appeared here in the returns table, only territories where a return was recorded in the data set. So as a result, product number 338 no longer exists because it's been filtered out as the context flowed up to the product lookup table. And as a result, as that context passes down to sales, product 338 is no longer even in the picture. So we've created a view that looks to be accurate, but it's invalid because we're missing some products that generated orders, generated sales, but did not show up in the return data set because they didn't generate any returns. So really fascinating stuff once you start to really dig in and understand what's going on. And that brings us to the final question in the homework. We've got to complete a few items for question number 5. And to do that, we're going to go back to relationships. First things first, we want to change this cross filter direction back to single or one way. So we can double click to edit, cross filter direction, single. Okay. And there you go. Now we've got our one way arrow. Next up, we want to hide the product key field in this returns table. I'm going to do it right here. Hide in report view. Boom, it's grayed out. We're done. Then update our matrix to show product key from the lookup table instead of the return table. Pull that out. And we've got our product table here, product key on rows. And we are done with the homework. So that wraps it up. That wraps up our data modeling section. I'd recommend that you do save some backup copies of this Power BI file elsewhere in your computer, but that just about does it. So next up, get ready to learn some DAX.